Okay. Good. Okay. It's working. Audio is okay. Everything is okay. We should be live. I think it's going now, the stream. Okay,
Luca Sannino non ha il badge, vorrebbe entrare.
Sto cazzo, già entrato ieri, avevo detto a conferenza no.
No, basta. Allora...
Io sarei per no, poi vedi tu. Metto lì?
Però non c'è il
Grazie.
tavolo qua.
Fa niente, tanto non ho bisogno del tavolo.
Perché? Come stai?
Un po' di casino, ma dai bene.
Cosa è successo?
Il video streaming è partito adesso, all'ultimo sembrava non essere in grado di farlo partire. Sì.
All right, 1 minute.
Di acqua da bere, ma vabbè,
Quello
al break. Sì, dai. Quindi i primi sono Adam Beck e Matt Corallo, Fungibility Overview, giusto?
useremo tipo... Wow.
Uno, due, tre, prova. Uno, due, tre, prova.
All right, everybody. Quiet, please.
Uno, due, tre.
Everything is in order. Sorry about a short delay. Good morning. Glad to see many of you again. My name is Anton Yemlyanov. I am one of the organizers of Scaling Bitcoin event. On behalf of Scaling Bitcoin Planning Committee, I would like to welcome everybody here to the third scaling event. We're holding this event here in Milan. Milan has a really vibrant community, vibrant Bitcoin community. It has been a real pleasure working with everyone here to create this event. The goal of scaling, as everybody knows, is to get everybody together in a single place, all engineers and academic community, so that we can discuss different scaling approaches and see how they can be applied to Bitcoin. I'd like to thank everybody who has submitted proposals for presentations. We have received a lot of proposals, and it has been a real challenge to pack them in 2 days. If we would have taken all of them, the event would have had to take place, take like 4 or 5 days. But I think, and there was a lot of interesting topics, and I think we've done a good job of creating an interesting and a strong program. So without further delay, I'd like to introduce Ferdinando Amiciano. Ferdinando is a professor, is a blockchain and Bitcoin professor at here at Politecnico, and former head of blockchain and virtual currencies at Intesa San Paulo.
So, welcome everybody. Welcome to all of you attending in person, attendees, speakers, and to the people that are watching the session through the streaming. As representative of the Milan community, I'm very proud. It's an honor for me to welcome you here. Anton was gracious enough to say that Milan has a vibrant community with blockchainlab.it, the AssoBit association. We have many developers here in Milan and have been trying to have a good meetup, monthly meetup. And so this Scaling Bitcoin is kind of a culmination of the last few months of involvement with this community. I'm especially proud to be here in Politecnico because Politecnico started this semester a Bitcoin and blockchain technology course, and so we look forward to have an exciting 2 days together. In order to have the best 2 days possible, I will urge everybody to please read the Code of Conduct, okay? Just devote 1 minute of your time to the Code of Conduct, and especially to the fact that since all the conversation will be under the Chatham House rule, the content of the conversation can be disclosed, but please, you cannot say who say that. Okay, so the source of the information cannot be disclosed. Of course, this does not apply to the presenters and speaker in session, which will be publicly broadcasted through the web. Especially, I want everybody to take note that no photographs or recordings are permitted. Okay, this is to respect the privacy of everyone. So, without further ado, it's my pleasure to introduce the Master of Ceremonies. This afternoon we will have Elizabeth Taylor, but in this morning we have an Italian representative, Giacomo Zucco.
Good morning, everybody. Good morning. So actually, I will be your MC for all the day, and I will pass the role to Elizabeth Stark actually tomorrow. So right now you are stuck with me. Please be advised that sharing comments about my bad English pronunciation is against the Code of Conduct. So this is the third Scaling Bitcoin event. Even if it's the first that is so crowded that tickets are being sold in the dark web right now, but okay, I think everybody here has a ticket. It's the third event about scaling Bitcoin, but it's called Retarget, and actually we will talk not just about scalability, but also about other very important issues that we have to address to make Bitcoin mainstream, bigger, safe, secure, and to make it fulfill all its promises. One of the topics that we are going to address very heavily during this event is, in fact, fungibility and privacy. Of course, it was also touched during previous edition, but there will be a special focus in this one. And so we start the events of today. We start this morning with an overview on fungibility. Of course, the speakers that I'm going to introduce don't need any introduction, actually. The overview on fungibility will be provided to you by Dr. Adam Beck and Matt Corallo, that I invite to come on the podium. Thank you very much.
All right, so let's get started. Oh. There we go. Okay. So let's start. So what does fungibility mean? So Bitcoin is like cash. It's immediate and final payment. So that, at least that's the hope. But maybe. So to add a bit more nuance there, you may have to wait for a few confirmations, or maybe it happens in one confirmation. But generally, once you receive a Bitcoin, you have a Bitcoin, and that's final. And so even with banks and PayPal, who sometimes shut down accounts for trivial reasons or even for no reason at all, it's typically not the case that if somebody who sent you money, so if you were selling something on eBay and somebody bought an item from you and that person had their account shut down, the money that you received would not be removed from your PayPal wallet. And yet this kind of effect that people multiple hops removed from you who are sending you Bitcoins, if they are associated with some trade on Silk Road or something like that, it turns out that some of the exchanges and hosted wallets are using sort of taint tracing services, and up to 4 hops deep away from you, if something is associated with the Silk Road, they will freeze your account and ask you to take your funds and your custom elsewhere. So that, if you look at it from this perspective, the reality is that for people using those services, fungibility in Bitcoin is actually worse than PayPal, because other people's actions which have got nothing to do with you, and you have essentially potentially no connection whatsoever with, 4 hops away is a very long way away. I dare say, potentially just about anybody with Bitcoins in their wallet who have done a few trades are within 4 hops of, anybody in the Bitcoin ecosystem potentially. It's a very interconnected system, like the kind of social networking theory that you're 13 hops from anybody globally. In a Bitcoin network, it's a smaller collection of wallets. So PayPal doesn't freeze your funds if one of your customers' customers use Silk Road, and apparently this is going up to 4 hops within Bitcoin. So another aspect of fungibility is that it's, everybody needs fungibility, or in effect, nobody has it. So that's because your lack of fungibility impacts everyone else. So fungibility costs are externalized. So if you're reusing addresses, that reduces the fungibility of other people's coins. And the usual kind of, I have nothing to hide, so I don't care sort of attitude, which can be true on an individual basis, actually degrades fungibility in Bitcoin generically and for everybody else, so that, if the 90% of people who, are just buying cups of coffee and don't have any particular privacy requirements take that attitude, there will be, very little fungibility left for the remaining users who would like a bit of privacy. And that fungibility failure can leak into the system and affect everybody. So Bitcoin being permissionless, so fungibility can affect permissionless effectively. So Bitcoin's permissionless is a critical feature, and you need fungibility basically for Bitcoin to function. If you receive coins and you can't spend them, you start to doubt whether it's safe to receive money. And if you in a system which there does start to be doubt about coins you received, what people will tend to do is go to the taint tracing service and ask them, are the coins I received good? Do you bless them or not? And if they're not good, you'll send them back or refuse the trade. And so what that basically does is it transitions Bitcoin from a decentralized permissionless system into a centralized permission system where you basically have an IOU from the blacklist providers. So obviously we don't want this to happen. If there's no permission, if you don't have permission to transact, you don't have Bitcoin essentially. And in the worst case, if everybody has to go to a central service to check if their Bitcoins are valid, or if they aren't, they have to sell them at a discount or that kind of thing, this can eventually lead to a collapse and a loss of confidence. And there are precedents within physical paper money as well. There are court cases in the distant past where this kind of concept that for a money to be functional, it had to be fungible. And so unlike, there are rules against receiving stolen property. If you unknowingly receive stolen property, like say a work of art or something, turns out it was stolen, you lose, you have to give it back. But with cash, paper money, that's not the case by law in most countries in the world. And this is because of this issue that if you can't have confidence in receiving currency, then it impacts, it makes the money non-functional and it impacts the economy. So, as I was saying, the attacks, the taint tracing is backwards looking. So it's not so much looking at, who received the money, but looking backwards up to 4 hops, who was involved in sending the money somewhat probabilistically. It's primarily focused on grouping transactions from individual or groups of senders, or the UTXOs, who owns those in the past, spent UTXOs. And this is in part, so there are a series of academic papers you can look up which look at sort of network analysis, and there are factors about the way Bitcoin is used that make this more effective and easier. So the fact that CoinJoin is not that frequently used, so most transactions, all the inputs come from a single owner. That tends to correlate multiple UTXOs as belonging to the same person. Address reuse is obviously bad, and another type of attack is is network address. So when somebody broadcasts a transaction, people will connect to many nodes in the network and try to identify the IP address of the sender. Another aspect is fingerprinting of wallets. So different wallets send slightly different types of transactions, like they might send a multi-sig, or they might send some parameter, so we're going to talk a bit more about those types of fingerprinting issue, which reduce the anonymity set. The anonymity set being a set of potential senders. And transaction censorship is another problem. So now we're going to connect. So fungibility can be in a trade-off with scalability, but there are some situations where fungibility helps scalability. And so we've got these 2 different logos which we'll use to score different techniques as we go through the rest of the paper. And sometimes fungibility brings a large scalability improvement. And an interesting fact is that the reason that fungibility sometimes helps scalability is because fungibility is generally aiming to reduce information leakage. And reducing information leakage means there's less information, and so there's sometimes less information that needs to go in a blockchain, so that's why. And conversely, if we have extremely high scalability in terms of the bandwidth and transaction throughput the network can support, that can also, in the other direction, help fungibility, because we can use some of the types of fungibility that use more data, like ring signatures and confidential transactions. So we talked about address reuse. So that practice has reduced. Most modern wallets are using HD. HD has strong advantages for backup. You do a one-off backup, and then you don't have to ongoing backup and risk losing funds. Another type of address privacy is the stealth address. It hasn't been so much used because it's difficult to find payments to yourself. You basically have to scan the network. So essentially, you either have to be a full node, or you have to rely on a third-party service to scan the network for you. So,
cool. All right, thanks, Adam. So moving on, I think this is transaction graph privacy. Refers to just the concept of people being able to scan the blockchain and analyze the flow of transactions. This is probably what people think of the most for fungibility. And I guess kind of the most obvious thing that everyone thinks of to solve fungibility is CoinJoin. And CoinJoin's great. Depending on how it's done, it can be a slight improvement in scalability, as we have with our little half rocket ship here, because it can reduce the size of transactions some. But it primarily focuses on increasing your anonymity set, so making it less private, making it more private as to exactly which inputs correlate to which outputs, which just makes transaction graph analysis a bit harder. It's not a massive win, but we'll talk about that in a second. So the next one, TumbleBit. So these guys are going to come up and present in, I believe, next. So I'm going to kind of leave that one mostly out, but TumbleBit's great. It's also a big scalability win. Lightning is obviously a massive scalability win, right? It came out of being a scalability solution, so it kind of wasn't originally designed to be a fungibility solution, but the folks working on it now even have onion routing for payments. So if your goal is to increase privacy so that it's harder to do analysis of where coins came from and where they're going, obviously onion routing is one of the big things that everyone thinks of. Everyone loves Tor. It's the same kind of technology. So it's great for that. Another thing that people think of a lot is ring signatures, which was kind of pioneered by Monero. So a lot of people like to talk about Monero as a more private Bitcoin. Monero is, the way it accomplishes having better privacy is to, for each input, instead of spending a given output, you say, I'm going to spend one of these outputs, and you don't know which one, and there's no way for you to identify which one, but you can validate that the transaction is valid, and you eventually won't be able to double spend, because if you try to double spend, the network can detect it. So this is also great. It, again, increases your anonymity set. It means that instead of saying, if you're doing graph analysis, instead of saying, like, this output definitely went to this input, you can only say, like, yeah, one of these 5 outputs went to this input. Those ring signatures are a bit more expensive, but more importantly, Monero has no concept of unspent transaction outputs. They only have transaction outputs, which is a big scalability loss. It just takes a lot more data to represent the chain. The next solution that we have kind of for input-output privacy is one-way aggregate signatures. So this is something that I don't believe any altcoin or anything has implemented, but one-way aggregate signatures are a wonderful idea where basically the effect on fungibility, you can see it as coin join for the entire block, every block. So essentially a block just becomes one large transaction every time, and you can't correlate inputs and outputs aside from the fact that they appeared in the same block. There's still a lot of attacks you can do with analyzing the peer-to-peer network and transaction relay, but it is great for, it's essentially coin join, which is great for fungibility. It does have some additional cryptographic assumptions. So the way that people have proposed doing one-way aggregate signatures is a bit kind of, let's say, weaker cryptographically. Not that it's strictly weaker, but it has been less studied, so it's kind of, less willing to put a ton of money, bet a ton of money that it is not going to die. Zcash is similar. Zcash is kind of an even bigger step towards fungibility. It hides essentially everything about a transaction. You can't see anything aside from the fact that a transaction happened, pretty much. It, however, has much bigger cryptographic assumptions. The ZK snarks on which Zcash is based are kind of very new and have been studied much less, but it is awesome technology. However, it is also highly unscalable. It is almost laughably large blocks and laughably large transactions and takes a long time to validate. So Andrew's going to talk about Mimblewimble in a bit, so I'll mostly leave it out. But it has OWASP type protection, ring sig type protection, happens to have really good fungibility properties, and has awesome scaling as well. So let's move on. I know we're moving kind of quick here, but let's talk about balance privacy a bit. So a big way in which people identify transactions as from the same sender, or at least are able to group transactions and split transactions according to different groups of senders, is balance privacy. So this is kind of the biggest example, right, is in a given transaction, you can see the inputs and outputs, and it's often very easy to correlate which output is the change just based on the balance, based on the output value. So a big way that people fix this in systems like CoinJoin is balance discretization. So essentially, instead of everything being Satoshis, you pick some larger value and everything is an order of, say, 1 Bitcoin or order of 0.1 Bitcoin. This is obviously expensive scalability-wise because you have more transaction outputs to represent the same value. But that is, in fact, where confidential transactions comes in. So CT is much more expensive cryptographically. It has a lot more operations, longer to validate, bigger kind of signatures, quote unquote, on the inputs. But it essentially gets you the same Zcash style privacy of balances where you can see nothing about a balance aside from that it was a valid spend of the previous output without needing to do any kind of discretization where you have to have a number of outputs per value or per output. Mimblewimble, of course, again, Mimblewimble is kind of a extended version of CT, but I'll let Andrew get to that but it is also awesome for balanced privacy. Zcash also, again, it has the same properties where you can't see anything about, essentially anything about the transaction coming in or out, but again, terrible scaling. So moving right along, let's talk about network attacks for a minute. Network attacks are kind of the biggest way that we see fungibility lost today. It is pervasive across the network. Right now, if you have a node that is online for a short period of time, and then you restart it, there is some chain analysis firm that makes 50 connections to your node instantly and reliably, and they're all clearly fake nodes. They're not. They claim to be some like Android wallet, but they're actually clearly not. They don't have the same behavior. That's kind of connect to everyone. That's very, very common. All of the chain analysis services do it, and they use it heavily to correlate transactions with where they came from, which happens to be a really good indicator of who sent the transaction. A big issue in networks today and kind of the privacy of users on the system is the BIP37 SPV Bloom filters. I'm sorry, I wrote that. It is terribly non-private. So there's been a bunch of posts. There was one in 2015. I think there were a few before that. Essentially, the way that the SPV wallets do blockchain sync today, they send your list of addresses effectively to all of their peers, and especially if you're one of these chain analysis services, this is massively detrimental because you're connecting to a chain analysis service and you're telling it, hey, here's the list of all of my addresses, go scan the chain and find which ones are mine, and then they can also connect which IP addresses are connected to you in the future, and they can watch as you move across the network. So this is massively detrimental, and we need to fix this. There's a few solutions that we have for that. Committed Bloom filters may be a solution. There's been some work put in on the mailing list and on some design work of doing just kind of flipping the way that people do scanning of the chain for addresses in a private way. Yeah, moving on, so I mentioned connect to everyone attacks, right? This is what most of the chain analysis services do. They make 50 connections to everyone, or they make one connection to everyone, depending on how competent they are. And this is terrible. But luckily, this is in fact one of the few slides where I can say that there's not just a lot of ways in which we could fix fungibility. This is something that we've been doing a ton of work on. Bitcoin Core has been put a lot of effort into improving the way it relays transactions so that it does not give up exactly when you received a transaction, so that people have a much harder time identifying and grouping transactions based on where they came from. In fact, in 0.12, transaction relay was made much more random, and someone claiming to be from a chain analysis service, it's unclear if it was actually the case, opened a pull request against Bitcoin Classic asking that this feature be reverted so that they can do better, more effective compliance tracking. This was obviously rejected from Bitcoin Classic as well, but yeah, so it is actually kind of really hard to get private transaction relay. There's been a ton of effort kind of just randomizing the order in which transactions are relayed out to your peers. And Bitcoin Core has made a lot of advances, but sadly randomness isn't exactly sufficient. Some various anonymity software like Tor and such, they've fought very hard to learn that randomness is not sufficient protection for your anonymity. As it turns out, if you have enough points, you can plot them, and you can see whether they match the expected random curve, whatever your curve is, that allows your random function, and you can then group transactions based on that. So it's not great. There's still more work ongoing in Bitcoin Core coming in 0.14 and later, but this is something that has gotten a lot of work. Moving on, there is, even though we've improved kind of transaction relay across the network so that if you connect to everyone, you can't find out where transactions came from, it's still the case that someone like the NSA or your ISP or someone who is man-in-the-middling lots of connections, say a global passive adversary, can identify exactly where transactions came from immediately. I'm going to let Jonas talk about BIP 151 tomorrow, but he's been putting in some work on fixing this as well. Finally, there's some infrastructure in Bitcoin Core, and I guess some of the forks of it, to enable actually private transaction relay. There's some research into how to do really private relay, if you're willing to wait some short period of time, let's say less than the inner block time for transactions to relay around the network using mixed nets. This might be overkill, but there's some infrastructure in Bitcoin Core where you can run an external daemon and all the transactions you create will just be handed to it, and it can do some crazy mixnet that's completely private and you can't identify where transactions come from. So that would be appreciated if someone actually went and finished that work. Yeah, so moving on, transaction features identification. So this is kind of goes back a bit to scanning the blockchain. There's a lot of these chain analysis services have become really good at identifying which transactions came from which types of wallets. So one of the big ones for this is coin selection, and I know Mark is going to talk about coin selection tomorrow, so maybe he'll get into this a bit more, but just so you're aware kind of the ways in which these services attack fungibility using this. A lot of coin selection algorithms kind of give away which output is your change output, and also which wallet you are using, just based on the kind of value of the change output and how it's selected. Additionally, a lot of the coin selection algorithms are completely deterministic. So if someone who is running a chain analysis service has a guess as to what your set of UTXOs is, and then you create a transaction, they can confirm whether or not they were right, and they can adjust their guess based on your transaction, which is really gnarly because you essentially give up all your privacy at that point. Finally, fee selection, just which fee you're using can also give away which wallet you're running. Next is scripts used. So this is a bit less about which wallet you're running and kind of what kind of services you're running. So I'm going to let Peter talk about Schnorr and how that's great for hiding kind of which type of multisig you're using tomorrow. But additionally, people have thought a lot about using mast, which is a concept of doing the Merkleized a Merkle tree over the script so that you can only reveal part of the script. And this is wonderful because what you can do is you can essentially say either a multisig of all of the participants, or we run whatever contract we are intending to run. And in this way, you can essentially, every transaction just looks like a multisig or something which you don't even have to reveal. So this obviously hopefully makes all transactions look pretty much the same, which is great for fungibility. Finally, ZK snark-based script systems. I don't think anyone's done this, and the performance is pretty gnarly for being able to do this. But this would be the kind of gold standard in that all scripts would just look the same. So finally, there's kind of a few non-script transaction features which give it away. For example, Bitcoin Core has a thing about incentive compatibility where it sends all transactions with a lock time of the current block height so that it can only confirm in the next block height. There's some reasons for doing this, which is great, and we would love all wallets to be doing this because there's kind of not any reason not to, but this currently gives away the fact that you're using Bitcoin Core. So the final kind of category of things which people are using to attack fungibility is maybe less something which people are using and more of a concern in the long term. Right? If someone can successfully censor your coins, if they can censor any transaction which spends your coins in some way, then your coins are obviously less valuable. So whether your coins now take a day to confirm or 6 hours to confirm, or maybe can't confirm at all, that is really nasty because your coins are now worth much less than everyone else's coins. So we really would like to create a social cost to transaction censorship. Right now, there's kind of no evidence that miners are doing anything gnarly here, but certainly, the point of Bitcoin is to not trust anyone, so we would not like to have to trust that miners are never going to do anything nasty with this. So, in the near term, as long as miners continue to be honest, we would like to have something in place where if in the future some miner, let's say in the US, were forced to censor transactions because the US likes to do things like this, then we would like the software to be notifying people and telling people like, this miner has gone bad, please stop using Bitcoin until we all go and beat them up. I'll fly to Washington and beat them up. So the final one's encrypted transactions. There's been a bunch of work put into thinking about this stuff. Essentially, you can commit to a transaction, and the chain doesn't know anything about exactly what that transaction looked like, which coins were moving, which is also obviously great for preventing transaction censorship, because if miners don't know what they're mining, then they can't prevent you from using your coins. So really quick, I know we have okay, we're out of time. But conclusions, if you were paying close attention, you might have noticed that a lot of the second layer solutions, the Lightning kind of things, a lot of the fungibility solutions we have involve essentially just moving transfers off-chain. This, as Adam mentioned, is incredibly powerful because it just means that there is less less knowledge of all of the data that's moving around, so it's much harder to attack fungibility. Sometimes just having more transactions improves your anonymity set, so it's harder to identify if there's more people, so that's also great. And most of these things haven't been implemented or aren't in heavy use. We'd like to see them used more, but we do know ways of fixing fungibility and making Bitcoin actually act like the currency we'd like it to be instead of like the asset which it sometimes acts as today. Thank you.
Thank you very much.
Right on time.
Thank you. Thank you. Thank you, Adam and Matt. Especially thanks to Matt for all the huge work that with all the program committee has been done to build this beautiful program that we will listen to today. So again, about fungibility and privacy, this was an overview, and we will explore some of the topics that have been addressed right now. The first topic was CoinJoin. CoinJoin can give some advantage for privacy and also some advantage for scalability itself. One of the problems is how to make people actually use CoinJoin. And so we have here Adlai Chandrasekhar to talk us about JoinMarket, which is actually a way to make people use CoinJoin and to create economic incentives to do that. Thank you.
Okay, so JoinMarket, just to clear up a misconception that I heard yesterday, I hope it was a joke, but just in case, JoinMarket, like Bitcoin, is a protocol. It is not a company. It is a protocol which is defined by an open source reference implementation, but there are other versions of the code out there, and it's entirely, I guess you could say it's voluntary, like Bitcoin. And those of you who might have less of a finance background might not be familiar with the term risk-free rate. So when you're investing, for example, fiat currency, the risk-free rate is considered buying government bonds. It's the least risky investment, and you get a very low return. And JoinMarket gives you the same thing in Bitcoin. So it's not just fungibility, it's also an investment method. I'm one of the JoinMarket contributors. The people who wrote the bulk of the code are also present here today, and I'll let them take responsibility if they choose. So just a humorous quote. Now, we actually haven't had a definition of fungibility yet. So fungibility is the property where equal amounts of some commodity, monetary good, whatever, are interchangeable. So in the case of mushrooms, you do not want to interchange a gram of one mushroom for another. But in the case of Bitcoin, most software will treat equal quantities of Bitcoin the same regardless of their history. It's people who actually go and look at the history and violate your fungibility. So together with all of the other efforts, we are trying to make their job more difficult. Another interesting quote from the cypherpunks list. More than 2 decades before JoinMarket appeared, Eric Hughes foresaw this development. And this is actually what JoinMarket gives you, very precisely. It's a way of transferring a non-private good in a more private manner. Now, he says anonymous, and that leads us to what is anonymity or privacy. More misconceptions I'd like to clear up before talking about JoinMarket itself. Anonymity is always within a set. There's this idea of an anonymity set. So you're one of a few billion people, you're one of a few million Bitcoin users, you might be one of around 1,000 JoinMarket users. If you're at a protest wearing a Guy Fawkes mask, you are one of those people. If you show up with the wrong mask because you like Mr. Robot, so you're wearing the F Society mask, suddenly your anonymity set is a lot smaller. So the purpose of fungibility systems is to grow your anonymity set, not just to get some sort of magical anonymity. There's also this quote of, there are two kinds of encryption, that which keeps out your kid sister and that which keeps out the government. I personally have nothing against kids nor sisters. This is Bruce Schneier's wording. And the same is true for privacy as well. You can, if I may mix metaphors here, you can fool most of the people most of the time, but you can only be a saint for 6 confirmations before the devil knows you're dead. So the government is going to know which bitcoins are yours. Maybe a nosy spouse can figure out which bitcoins are yours. We are more focused on giving people privacy that stands up to less funded tracking startups and to casual observation. There's also the concept of hiding and the concept of deniability. So tracking startups that say this customer of yours is using the darknet or they're gambling, they can't actually prove that. They are simply saying, we found a link. It's a very likely link. We estimate it at X%, but they can't prove that that link is you. So you have deniability from even regular Bitcoin use. We try to give you better deniability, but you have to go to great lengths to actually hide, to have people not able at all to tell what your transaction graph is. Essentially, if you get enough deniability of enough different plausible explanations, you are hiding behind a smokescreen of possible interpretations. So before JoinMarket, users would just use all sorts of arbitrary methods. They would buy an altcoin, send it to another exchange, sell it back, send through different wallets, send through gambling sites. And arguably, these methods even, they give you worse privacy. So there emerged sites dedicated to unlinking. They called themselves tumblers, which is a reference to coin tumbling. When you collect physical coins and they're dirty, you can mix them with sand and water to clean them out. And this is actually a misconception because when you use a fungibility technology that everyone else is not using, your coins become dirtier. People like a tracking startup will look at your coins and say, oh, this person is trying to be more private. So what you get here is that your personal transaction graph might be more difficult to track, but overall your coins are distinguishable as privatized coins. Now, Greg Maxwell proposed CoinJoin and CoinSwap in 2013 on Bitcoin Talk. CoinJoin has gained traction. CoinSwap, unfortunately, has not. The best marketed CoinJoin implementation was Dark Wallet, which worked. You could use it to produce CoinJoins without a central server. Unfortunately, you had to wait a very long time. You had to wait hours, days, until enough people with enough Bitcoin were online at the same time, and then you could make a CoinJoin. Now, just in case anyone here has not seen exactly what a CoinJoin looks like, this is arguably the simplest smart contract. We have, in this case, 2 participants, both with 0.8 Bitcoins. One of them has them in one output in the middle, this one. The other one has 2 outputs, the first and the third one, and they each get 0.8 Bitcoins out. And there's no way for you, just looking at this transaction, to know which output corresponded to the middle input and which output corresponded to the first and third inputs. So JoinMarket's goals emerged out of that status quo, that prior art that I described, mainly the pain of using Dark Wallet. So first of all, no counterparty risk. We don't want to be a centralized mixing site. We are not going for strong privacy. Strong privacy is difficult to achieve. It uses complicated mathematics, which definitely most Bitcoin users don't understand, and possibly even most people. It has to be a liquid tool. It has to be highly available. You need to be able to show up with dozens or hundreds of Bitcoins and actually perform coin join right away. And JoinMarket meets this goal. You can make dozen Bitcoin coin joins instantly with several different counterparties, and you can even make coin joins with hundreds of Bitcoins, although that's less liquid. It has to be compatible with the existing vanilla Bitcoin protocol. And some people might not like this attitude, but we do not want to require our users to install any different software other than what client they have today. So if you use some funky old Bitcoin client from 5 years ago and it doesn't have an RPC command, which we use, that's a bug as far as we are concerned. Please let us know. And finally, it's probably pretty obvious, but we want a system which can be used. If it's not usable, it's not useful. We are going for a working tool that people can use as soon as possible. So JoinMarket's fundamental innovation, which I believe several people came up with independently, is that you compensate people for participating in the protocol. And this achieves both the fact that people are incentivized to stay available, they leave their JoinMarket clients running, what they didn't do with Dark Wallet, and it brings in additional liquidity. People who don't care about fungibility do care about making money. So they run the JoinMarket software, they increase your anonymity set as a user of JoinMarket, and these are people who are investing dozens or hundreds of Bitcoins. They would not leave those in a hot wallet. They would put them in cold storage and forget about them for a year or more. Instead, they're now running hot wallets, which we hope are secure, and they are increasing other people's anonymity sets. So JoinMarket divides participants into two different roles: the passive participants, or makers, and those who initiate transactions, or the takers. The passive participants are always running, whereas the initiators initiate a transaction and then disconnect. Initiate another one, disconnect. If you're a participant, you just sign transactions that look okay to you. If you're an initiator, you're actually responsible for coordinating the entire transaction, talking with the counterparties, building the transaction. So the initiators pay fees and the participants earn them. Now, because the initiators are coordinating the transactions, they actually learn some information about the other participants, which means that the regular participants get less privacy than the initiators. If you want the best possible privacy, you have to pay for it. So we're going to run through the protocol quickly. If you want to get a precise sense of it, you have to read the code itself. The participants advertise publicly how much liquidity they have and what fees they're expecting to get. The initiators pick which counterparties they want, and they contact them with an encryption key and the amount they want to transfer. Remember, in CoinJoin, everyone has to have the same amount of output, so you need to know the amount. The participant replies each one separately with their encryption key, and from this point onwards, everything happens with end-to-end encryption in a kind of hub and spoke model, where the initiator has an end-to-end encrypted channel with each participant. So now the initiator signs their encryption key with the Bitcoin key. We don't use the Bitcoin keys for the encryption itself, but we do sign the encryption key so that you know you're actually talking with someone who owns those Bitcoins rather than just someone who wandered in. The participants reply with the unspent outputs that they want used as their inputs, and with the addresses to which they want the equal-sized CoinJoin output and their change. Also, they sign with a Bitcoin key. The initiator constructs the transaction, sends it to the participants, they sign, the initiator signs, and broadcasts. And that's how we get CoinJoin. You may notice a problem here. The initiator is the last one to sign. So what if they don't sign? They've actually learned the mapping. They've learned which inputs belong to which makers, and they know additional unused addresses of those makers. So if they don't sign at the end, they've learned this for free. And this attack was known for a while. We didn't want to not release a project with some theoretical attack, but over the course of the summer, this attack began to happen in practice. So we saw the successful transaction count increasing, but in parallel to that, very suddenly there appeared about 3 to 10 times as many failed transactions, where someone would start the protocol and break it off partway after learning your mapping. And we call this a snoop attack. It's not a Sybil attack. That was another misconception people had yesterday. So the snoop attack is free. It doesn't cost the snoop anything. So we've come up with a second protocol, which is released and running, which ameliorates this attack. It can't be prevented entirely. Notice that if you really want to know people's mapping, you can just pay for the transaction, complete it, and you've paid a bit of money, but you still learn the mapping. So the second protocol has the same basic sequence. We took this opportunity to add a signature on every message. And the key thing here is that the takers don't just sign the encryption key with a Bitcoin key. They actually commit with a unique commitment to some Bitcoin, some unspent Bitcoin. It doesn't even have to be the same one. Now, what does it mean that this is a unique commitment? Every Bitcoin that exists currently generates one commitment. And if you've seen a commitment, you can't figure out which Bitcoin created it. But if you see the same commitment again, you know it's that same Bitcoin. If you see a different commitment, you know it's a different Bitcoin. So this lets the makers, the participants, not talk to people who are initiating multiple transactions. Effectively, it puts a cost on snooping. You can still snoop, but you have to create new coins each time. It's a very, very cheap rate limiting. And we've not yet seen anyone conducting a snoop attack on the second protocol. So either this was a sufficient discouragement, or they're simply writing code and collecting funds, and the snoop attack will continue. That remains to be seen. Now, future directions. We have 2 wallet integrations that are pretty much written, although they need more review and testing. That's Electrum and Core. We have a hybrid mode which doesn't quite work yet, where if you don't have to make a transaction immediately, you can participate in other people's transactions and possibly even earn more than the fee for your own transaction. We want to expose an API so that existing services can benefit both from the interest of a hot wallet. Any exchange would have every reason to use this. And so that an exchange could, for example, offer its customers withdraw with CoinJoin. And I believe one of the testnet faucets does this today, although not in a very programmatic manner. We want to gather statistics on the economic activity that's happening here. JoinMarket is the first market of its kind, and there are a lot of Bitcoin flowing through it. There was an estimate of about $1 million a month. I didn't calculate it, so I'm just quoting it. And people are earning money here. Some participants earn more than others. We want to look at how much are people earning, what's the variance between that, what are the optimal fee strategies, how can you maximize your earnings. So there's a lot of unmined data here, and it's just sitting in the blockchain. It's all public. We want a tool that lets people gauge the privacy improvement that they could get and that they got after using JoinMarket. Because right now, it's pretty obvious that doing a single coin join is almost useless, and that doing 100 coin joins is pretty confusing to anyone who's tracking you, but where do you draw the line? Do you do 5 coin joins? Do you do 50 coin joins? So we need some tool that lets people figure that out, because these cost money. People are paying per coin join. And we want to implement CoinSwap, because the cool thing about CoinSwap is that whereas in CoinJoin, the anonymity set of a single CoinJoin is the participants in that specific CoinJoin, in CoinSwap, the anonymity set is everyone who is doing a CoinSwap at the same time, even if they weren't coordinating directly with each other. I'm not going to go over how the CoinSwap protocol works, but achieving that level of anonymity set increase using chained coin joins is a lot more expensive, and I doubt that that's the right strategy. The right strategy is to offer the additional protocol. So, questions, please. How are we for time?
Okay, we have 6 minutes.
Yes, any questions? Any questions
One
from
question
IRC?
there.
Yes.
Can you characterize your, are you looking at the coin shuffle approach that increases the decentralization and some of the security aspects, or what, can you characterize your approach with respect to that?
So coin shuffle.
Can you repeat the question for the people watching on the live stream?
Well, I'm paraphrasing here, but the question was, how does this compare to coin shuffle, essentially? Correct me if your question was more specific. So coin shuffle, for people who aren't familiar with it, is a protocol which results in a coin join transaction, but the way it's created is more private per counterparty, per participant, than simply everyone telling one coordinator, here are my coins, I want them to go here. It involves several stages of messaging between the participants where they incrementally add blinded information and unblind it, and eventually it results in a regular coin join transaction that can be broadcast to the network and is indistinguishable from regular coin joins that we make. So it is an improvement. It's a more complicated protocol, which means that it's lower priority.
But it solves some of the problems you seem to be calling out there, especially the de-anonymization problem. So that's why I would think you might be interested in it.
So it solves the most naive version of the snooping attack. The problem is when you combine a snooping attack with a Sybil attack. There's nothing preventing a single person or a company from running multiple JoinMarket clients. And if you have a larger number of JoinMarket clients, a large number of participants, or if you're initiating multiple transactions, then you can eliminate the coins which you know belong to you, and you can see which ones belong to the other person. If you manage to isolate a single participant, for example, if you run 3 participants and the initiator, and you simply contact one additional participant, you get the same information that the current snoop gets. It'll cost you capital expense because, and it's not exactly a cost, but you have to tie up Bitcoins to run the participants, and you have to pay fees or cycle new UTXOs, but you still learn that information. So it's also not a perfect fix.
Yeah. So yeah.
Yes?
Do you have any idea what percentage of JoinMarket users are using onion routing?
Too late.
That's a good
Can you repeat the question again?
Okay, what percentage of JoinMarket users are using onion routing? I assume that means Tor, because I would be surprised if anyone is using I2P. I'm not even sure you can connect to the servers we're using right now with I2P. We use servers merely for the communication channels. The servers don't have access to the information that's end-to-end encrypted, although they do see the activity levels. So they get some information. The question, though, was what percentage are using onion routing? I know that it's definitely supported by the code. You simply have to change false to true, and you get onion routing as long as you've got Tor running on the same computer, or you configure the address. We've not collected that information because we're not spying on our users. More questions?
Yeah.
Yes.
You mentioned something about coin swap versus coin join. Could you elaborate your comments on whether you see doing future work in the direction of coin swap, or if you think more of the future work should be in coin join?
So a bit of a personal story. I am one of those who independently thought of this incentivization idea, and I imagined it with CoinSwap. So I think building CoinSwap from the start is a much more, let's say, scalable solution, because you get the large anonymity set from the beginning. You do have to agree that everyone coin swaps at discretized amounts. If you have one coin swap happening with a size of 1 Bitcoin in parallel to a coin swap of 2 Bitcoins, it's pretty obvious that they're not the same people. But if everyone's making coin swaps in sizes of 1, 10, 100, 10th, 100th, etc., then you have these tiered anonymity sets. So I see that as a much more scalable solution. I believe, I don't have hard numbers on this, but I believe that to achieve the same size of anonymity set using parallel coin swaps or chained coin joins, you would end up putting a lot more data in the chain using coin joins. The way JoinMarket works right now, we're actually bloating the chain because each initiator creates a large transaction that's some constant factor larger than a regular transaction. Whereas CoinSwap, an individual coin swap is 4 transactions total, whereas CoinJoin is a single transaction. But those 4 transactions happening in parallel with another pair's 4 transactions and another pair's 4 transactions can give you roughly the same anonymity set as, throwing out a number here, 1 coin join of 6 participants, which is more difficult to coordinate, or many coin joins. You need an entire network, a switching network of coin joins of fewer participants. If you have 50 people doing coin swap in parallel, you would need a tremendous network of coin joins to even come close to that anonymity set. The main challenge with CoinSwap is that it's a much more stateful protocol. You don't simply negotiate, exchange information, sign, and broadcast to the blockchain. You fund multi-signature addresses, and then you exchange information, and then you either take out your new coins, or you have to wait for a lock time to expire and get back your old coins if the counterparty vanished. So just in terms of implementing it, CoinSwap is a more complicated protocol, which is why the consideration of usable is useful has dictated that CoinJoin appeared first.
Thank you very much, Adoy.
Thank you.
Thank you. So how Matt previously anticipated, we are now going to see the details of the TumbleBit, an untrusted Bitcoin-compatible anonymous payment hub. And we are having Ethan Heilman and Lynn Alshabin to present. Thank you very much.
Hi, so I'm going to be talking about TumbleBit, which is our untrusted private Bitcoin payment system. So TumbleBit provides payments which are private, so they're unlinkable when used as a payment hub, or provide set anonymity when used as a classic Tumblr. They're untrusted, so no one, including the Tumblr, can steal your Bitcoins or violate your privacy. And when used as a payment hub, it's scalable. Furthermore, it's compatible. It works with today's Bitcoin. There's no malleability concerns. And this is somewhat tricky because we're going to have to rely on the very constrained opcodes that currently exist in Bitcoin to do some of this cryptography. So there's 2 ways to use TumbleBit. The first way is to use it as a classic Bitcoin Tumblr that provides k-anonymity. This is, you can almost think of this as more private version of CoinSwap. So it has 4 transactions that are confirmed in 2 blocks, so it has a minimum mixing time of 20 minutes. And then we can use TumbleBit as a payment hub. So this provides unlinkability within a payment phase, but payments are confirmed within seconds because they're off blockchain, and they don't take up space because we're going to be using unidirectional payment channels. So before I explain how TumbleBit works, I'm going to do a brief reminder of a unidirectional payment hub, and then I'm going to evolve that into TumbleBit. So Alice and the payment hub have a unidirectional payment channel. The payment hub and Bob have a unidirectional payment channel. This is implemented with 2 escrow transactions, which are 2 of 2 multisig. So they require both parties on each end of the escrow to sign off to spend that escrow. So Alice wants to pay Bob through the payment hub. So she does a claim transaction. The payment hub creates a claim transaction as well. And to authorize this payment, Alice signs that claim transaction. The payment hub signs the second claim transaction. And then when they want to close the channel, the payment hub can sign claim 1, Bob can sign claim 2, and the payment goes through. So the payment hub gets 1 Bitcoin and also sends 1 Bitcoin on to Bob. But there's a problem with this. The payment hub could be malicious and just take Alice's Bitcoin and never sign the second claim transaction and walk away with the money. So one of the traditional strategies is to make claim 1 and claim 2 atomic. So they either both happen or they don't happen at all. You can see that this would actually fix the problem because it's this lack of atomicity that allows the payment hub to solve. So one of the ways this is done is with hash locks. You have h of x, so you have some value x, and the claim transaction can't happen without x. So even if the payment hub signs it, Bob can't take the money until Bob learns x. So Alice creates a second hash lock that uses the same x, and when the payment hub claims the funds, it has to release that value x. Alice can tell Bob what this x value is, and then Bob can take the funds. So using these hash lock transactions, or HTLCs, the payment hub can prevent theft. The problem, though, is that if you have a bunch of people using this, the payment hub can link the hash locks that are used. It can see that Alice 1 is paying Bob 2 because they both are using the same hash value, hash input preimage. So it provides no privacy from the payment hub. So the main idea behind TumbleBit is to provide this atomicity, but in a way that's unlinkable. So the payment hub can't see which transactions are atomic, but they'll still be atomic. You can kind of think of it like unlinkable or private HTLCs. So the main cryptography I'm going to use to do this is RSA. And we introduced the idea of RSA puzzles. And an RSA puzzle is just a textbook RSA encryption of some value epsilon. So and it's always going to be the Tumblr that's creating these RSA puzzles. So the Tumblr has a public key, and it performs the RSA operation on epsilon and generates Z, which is our RSA puzzle. Now, notice that the Tumblr has a secret key, and because the Tumblr is doing textbook RSA encryption under its public key, only the Tumblr can solve these puzzles. So if the Tumblr is given a puzzle Z, it can use its secret key to invert the operation and get epsilon back. So the Tumblr can issue these puzzles, and the Tumblr can solve these puzzles. But the nice thing about this is that we can use RSA blinding to blind the puzzles. So we have a Tumblr. The Tumblr gives out 2 puzzles, Z1 and Z2, to 2 different Bobs. Bob 2 blinds his puzzle to Z star and sends Z star to the Tumblr. And the Tumblr can now solve this and end up with a blinded solution, which is epsilon star, and send it back to Bob. And Bob can now unblind this epsilon star to the original solution to Z2. And if Bob does this over Tor, so the Tumblr doesn't realize the Tumblr's talking to Bob, the Tumblr can't link which puzzle it solved. It knows it solved a puzzle, but it doesn't know whether it was Z1 or Z2 because the puzzle that was sent to the Tumblr was blinded. So TumbleBit has this, is sort of based around this idea. So what the Tumblr is going to do is the Tumblr is going to say to Bob, if you solve this RSA puzzle, I'll give you 1 Bitcoin. So, and the Tumblr says to Alice, I'll sell solutions to RSA puzzles. So you can see how this might allow Alice to pay Bob. Bob gets a puzzle, asks Alice to solve it. Alice pays 1 Bitcoin to solve it, sends the solution to Bob, and Bob then redeems 1 Bitcoin. So On the right side here, Bob's going to do a protocol where if he learns this solution epsilon, he'll get 1 Bitcoin. And on the left side, we're going to do a fair exchange of 1 Bitcoin for a solution to a blinded puzzle. So first I'll explain how Bob does this, and then I'll fill in the fair exchange here once we've completed the Bob side of the protocol. So the Tumblr is going to create an RSA puzzle with the solution epsilon, and then it's going to take a signature, an ECDSA signature, and encrypt it under the solution to the RSA puzzle and create this ciphertext C. Now, this signature is actually going to be the signature to a transaction that allows Bob to spend 1 Bitcoin out of this escrow. So notice that if Bob learns epsilon, he can decrypt C to get sigma. And so if Bob solves this RSA puzzle, he can learn a signature, and he can use the signature to claim 1 Bitcoin. So the Tumblr sends the puzzle and the ciphertext to Bob. Bob blinds it, sends the blinded puzzle to Alice. Alice performs a protocol here and gets the blinded solution. Bob can now unblind this puzzle, decrypt the ciphertext to get the signature, and now Bob has a valid signature on this transaction and can get the coins from there. I'm going to talk about the fair exchange from Alice to Tumblr, but I want to note that you could actually use zero-knowledge contingent payment here. Basically, what's happening is that Alice wants to trade a solution to some puzzle for a Bitcoin. We don't actually use zero-knowledge contingent payment. We've created a very performant protocol because this is 2048 RSA and would be fairly slow in ZK snarks. But this part could clearly be solved by a ZKCP. So Alice sends the blinded puzzle to the Tumblr. Similar to the Tumblr's earlier actions, the Tumblr is going to solve the blinded puzzle and get epsilon star. But notice if the Tumblr just told Alice epsilon star, then she'd be able to get money without paying for it. So the Tumblr is going to encrypt the solution using this key X, and is going to hash X to this value Y, and then send the ciphertext and Y to Alice. So if Alice learns X, Alice can decrypt Q and get epsilon star. And then Alice is going to create a transaction which offers 1 Bitcoin from this escrow if the Tumblr reveals this value X. And if the Tumblr takes that 1 Bitcoin by revealing the value X, Alice can now decrypt Q and get epsilon star and then send that back to Bob. The problem here, though, is that the Tumblr could not play fair. The Tumblr could generate C here that's just some random value, and then when Bob goes to decrypt it, Bob wouldn't get a valid signature. And also the Tumblr could play games here too with just do crap. So the way that we solve this is we have 2 protocols. One is called the Puzzle Promise Protocol, and this protocol allows the Tumblr to convince Bob that the solution to the RSA puzzle is a value E, which allows him to learn a valid signature on his transaction. And the other protocol is the Puzzle Solver Protocol, where the Tumblr convinces Alice that the preimage X will allow her to learn epsilon star. Both these protocols are actually fairly similar. They use similar tricks. If I have time, by the end of the talk, I can go into the Puzzle Solver Protocol, but I might not have time for that. But I do have a slide, so if anyone wants to go more into the details, I'll be happy to show them this. So TumbleBit uses 3 phases. In the first phase, all the payment channels are set up, and each of the Bobs are given ciphertext and RSA puzzles. Now, we want to be able to make multiple payments. We don't want a payment channel that you can only use once. So there's actually additional ciphertext and RSA puzzles. Each one gives an additional Bitcoin to increase the payment channel. But we don't want Bob just to solve the last one and say get 10 Bitcoins. So each puzzle is actually locked until Bob finds the signature and then can use the signature to unlock the next RSA puzzle. The next stage is the payments phase. So this is where payments happen. We imagine this maybe about like 1 1 month or less than that. So let's say Alice wants to pay 1 Bitcoin. She pays 1 Bitcoin to the Tumblr using the fair exchange, and Bob receives a signature, which now allows him to increase that payment channel by 1 Bitcoin, and also unlock the next puzzle. Alice pays again, Bob gets another signature, unlocks the next puzzle, another Alice pays and unlocks another puzzle and gets another signature, and we can imagine lots of these payments happening. I've only drawn 4 signatures here, but there's a ... This actually goes to 10. And at the end of the payment phase, we have a cash out phase. Now, the cash out phase allows everyone to take their money out of these payment channels. So Alice 1 spent 5 Bitcoins, so the Tumblr gets 5, and the same for Alice 2 sends the Tumblr 3, and so on. Bob 1 got 2 signatures, so he can use the second signature to sign a transaction that gives him 2 Bitcoins. Bob 2 actually got 10 Bitcoins, so he can sign a transaction that gives him 10 Bitcoins, and so on. So the privacy offered by the TumbleBit payment hub, well, let's look at what the Tumblr sees. The Tumblr sees each time an Alice paid. It knows the time, and it knows that Alice paid someone, but it doesn't know who Alice paid. At the end, the Tumblr learns the aggregate value that each Bob got, but not when those Bobs were paid or who paid in. So the Tumblr sees the payer of each payment, and it sees the number of payments each payee received. So our unlinkability definition is that all interaction graphs, so this Alice, say, spent 5 Bitcoins, and this Bob got 10 Bitcoins. We refer to an interaction graph as any way this could have happened between all the parties. So we're unlinkable in that all interaction graphs compatible with a Tumblr's view are equally likely. So this could happen, or this could happen, or this could happen. Now, I've only showed a few interaction graphs, but there could be an extremely large, any interaction graph which ends with this Bob getting 10 and this Alice sending 3. They're all equally likely. There's no way that Tumblr can figure out which set of interactions led to that. And Lean will now explain this part.
All right, so as Ethan mentioned, TumbleBit can also be used as a classic Tumblr, which allows users to move coins to an unlinked fresh address. Oh, sorry. All right, so as you can see, an old address goes through the Tumblr and then gets a fresh address, and you can't tell what the old address was. And to run TumbleBit as a classic Tumblr, you would basically open a payment channel with the value of 1 Bitcoin that can only be used for 1 payment. And in this case, we'd have an equal number of payers and payees, which offers us a K-set anonymity, where K is the number of payers and payees. So to solve the anonymity problem, a number of schemes have been proposed, schemes that propose new cryptocurrencies like Zcash or Monero, and schemes that are Bitcoin compatible, which are like mixers. So blind coin is vulnerable to Bitcoin theft, while CoinSwap can break anonymity. CoinJoin and CoinShuffle are vulnerable to DOS and Sybil attacks, and CoinShuffle has a limited anonymity set since it's limited by the transaction size, which is just 100 kilobytes. Zim is not vulnerable to any of these attacks, but takes a long time to run. And so we have implemented a proof of concept implementation of the classic Tumblr, and we're currently working on improving it, and we have the source code and the development roadmap available on GitHub. So our implementation is performant. It only consumes 326 kilobytes of bandwidth. Most of the time is spent on the puzzle solver protocol, and if you run TumbleBit on the same machine, like with the server and everything, it only takes 0.6 seconds. If you run the server in Tokyo and like both Alice and Bob in Boston, it would take 6 seconds, and if you run them through Tor, it would take 11 seconds. And yeah.
So in conclusion, TumbleBit provides private, untrusted, scalable payments on today's Bitcoin. We have running code for the TumbleBit Classic Tumbler. Our code runs on, we've run our code on Bitcoin's mainnet blockchain, so you can go and look at our tumbles. We've published our code on GitHub, so you can read it. But we're working to improve the code and make it easy and safe to use. Currently, it's a proof of concept. It works. You can run it. But we want to make it far more secure. We wanted to prove that we could do it, but making it safer for users is going to be what we're going to be working on now. And we are trying to hire a full-time engineer, so email me if you're interested. And I believe I have enough time to explain one of the protocols, so I'll come back to questions. So the puzzle solver protocol, remember this is the one that allows Alice to exchange a blinded solution for a blinded puzzle for a blinded solution. So we want it to be fair exchange. So we want Alice to pay the tumbler if and only if the tumbler provides a valid solution, and the tumbler reveals the solution if and only if Alice pays. So we don't want either party to be able to cheat each other. So Alice gets this Z star from Bob. And what she does is she's going to create M, what we call real puzzles, and N fake puzzles. Now the real puzzles are actually all blinded versions of Z star. So Z star is going to be double blinded. And so she just takes Z star and blinds it again and makes M of these. And the fake puzzles are going to be values that Alice chooses and that she then encrypts under the tumbler's public key. So she actually knows the answer to these. And she's going to shuffle them together and send them to the tumbler. And the tumbler can't tell which ones are real and which ones are fake. It doesn't know which ones are going to be the fake ones and which ones are the actual answer that Alice wants. So the tumbler is going to solve all of these. It's going to provide the solution to every single one of these puzzles that Alice has sent. It can't send the solutions back because then Alice would be able to take the money. So what the tumbler is going to do is it's going to encrypt each one of the solutions under a different X, and it's going to hash all of these X's to get a hash output Y, a different hash output, and send these to Alice. And so it's in this stage, the tumbler is essentially like committing to these solutions without revealing them. Alice is going to then reveal which one of them are fake. So she says to the tumbler, if you tell me the solutions to these, I don't learn anything new because I actually already know the answers. So here are all the answers to the fake puzzles. The tumbler checks that these are in fact real answers to the fake puzzles, and it's going to reveal the keys that allows Alice to decrypt these fake puzzles. And so Alice can check that all the fakes were actually computed correctly, that the keys actually hash to Y, and that when you decrypt it, you actually get a valid answer. So Alice proves all the real puzzles unblind to the same puzzle. So she actually gives all the blinding factors over so that the tumbler can see that she'll only be getting one answer. And at this point, they're good. Alice provides a transaction that actually asks for all the X's to the reals. The tumbler provides all the X's to the reals. And so the tumbler gets paid 1 Bitcoin. Alice gets paid, Alice learns all the X's, which he can use to decrypt all the Q's and learn epsilon star. Now notice that if the tumbler computed any of the reals correctly, Alice will learn epsilon star because all the real puzzles are actually all to the same Z star. And that if the tumbler tries to cheat Alice, the tumbler must corrupt all of the real puzzles. It can't just corrupt some of them. And if the tumbler corrupts any of the fake puzzles, Alice will see that a fake puzzle has been corrupted. So the tumbler has to guess exactly which puzzles are the real puzzles and only those puzzles and corrupt them. So the probability that the tumbler cheats successfully is the number of real puzzles plus the number of fake puzzles choose the number of real puzzles. And so for our values, 15 and 285, this is 1 over 2 to the 80. And we chose this number because this is the collision resistance of right bend 160. And so this is a very small number. Let's see. So I can answer any questions.
So 2 questions. We are running a little late.
How do you attract liquidity? Is your plan to build this into a central part of the protocol, or are you going to have other hubs that people have a reason to add their coins to? And if so, how do you incentivize them? Are you going to pay them for adding their coins?
So I think this is a question about incentives and setting up the system. So I didn't talk about it whenever I showed it. It was always like 1 Bitcoin for 1 Bitcoin. But it's very easy to build a fee into it. You probably would only want like 1 or 2 of these because the more people that use it, the better the anonymity provided.
Yeah, Brian Ford from EPFL. Very cool, interesting work. I like the kind of the clever use of Chami and eCash for this purpose. So one issue, though, I don't quite understand how or why, on what basis you're asserting that this approach is less vulnerable to Sybil attacks than others like CoinJoin and CoinShuffle. In that it seems like the Tumblr, maybe there's 1,000 Alices and 1,000 Bobs, but 999 of the Alices and 999 of the Bobs might be fake Alices and Bobs that the Tumblr created, right? So how do you, how is this any better than in the CoinShuffle or CoinJoin world?
In terms of comparing it to CoinShuffle or CoinJoin, one of the advantages that a Sybil attacker has is that a Sybil attacker can abort. And so if the Sybil attacker doesn't win in any particular round, it can start that round over again. CoinShuffle does have some protections against this.
Yeah, that's precisely the problem that CoinJoin has, but CoinShuffle does not, so that CoinShuffle solves.
So CoinShuffle solves it in the sense that someone can't abort again, but they get at least 1 abort, right? So if you have multiple Sybils, they just didn't get all the Sybils, they can do the abort. The other issue, and I didn't actually talk about this, is that we have these anonymous fee vouchers. So in the classic Tumblr mode, we use that to place a cost on the Sybils. So if a Sybil fails to de-anonymize a particular round, it just fails and that round happens. It can't re-abort. And each time it wants to try, it has to pay money, so it can't just leave and not pay any money. Within the payment hub scheme, we required that people lock some Bitcoins in escrow in these payment channels, and that these payment channels, like a coin swap, all sort of add on top of each other. So if you just want to add, say, 30 Sybils, and there's 100 people that want to play, you don't get to replace any of those 100 people. You just add 30 additional Sybils, so that doesn't degrade the protocol. That doesn't degrade the anonymity set offered.
Okay, I think we are. Thank you very much. Thank you, Ethan. Olive. So a little bit late, but we're going to have a very anticipated talk about something that can be very interesting both on the side of scalability and on the side of fungibility and privacy. In Bitcoin, there is quite a story about anonymous papers popping up. And so Andrew Postra will talk about Mimblewimble protocol. Thank you very much, Andrew.
Oh, it went away. Oh, this is right, this is left. Cool, how do I point? How do I point it, Anton? Yeah. Awesome. All right. Hi, guys. I'm Andrew Polstra from Blockstream.
I am here to talk about Mimblewimble, which is not my, Mimblewimble is not mine, it belongs to the Dark Lord, but I'm going to explain it a bit and talk about that. So I'm going to start out, I'm going to talk a little bit about the history of this paper. As has been mentioned, this has been in the news a little bit, and there's all sorts of weird, mysterious things around it. Then I'll talk about the transaction structure, the block structure, try to explain the trust model a bit of Mimblewimble, and argue that it's as strong as that for Bitcoin, even though it is actually a bit weaker. There's less data you can verify. If I have time, and I don't think I will, I might talk about some extensions I've done to the protocol to further increase its scaling beyond what's already possible. And then just go over next steps, open problems, that kind of stuff. So, start with the history. So this started out, I guess, over 2 months ago. On August 2nd, on the IRC channel, Bitcoin Wizards, somebody logged on with the nickname Major Player and just posted a link. He said, I wrote this paper, some friends of mine said that this channel will be interested, so here it is, signed off. The paper, which the next morning I woke up, this is in the middle of the night for me. So myself and Brian Bishop, who host a lot of files related to Bitcoin, checked that this was actually a text file. I mean, it was some random .onion link that somebody signed onto IRC and signed off. It was actually a text file. It was a document called Mimblewimble. It was signed Tom Elvis Jedusor, which is the name of Lord Voldemort in the French Harry Potter books. So it is unlikely this is a real name. But that is a name that we have. So I should mention a little bit. So I was actually working on something similar, not similar, similar but much smaller, a couple weeks before this. So when I encountered this, I was able to go like, okay, this is what I was working on, but much more powerful. It was very exciting to me. So after the next week or so, I spent a little while trying to read this paper, trying to understand what it was doing exactly. I thought it was the same as the stuff that I was doing in Elements. Actually, it was not. So I had a number of discussions on Reddit and on IRC, in particular with Greg Sanders, who broke a lot of my assumptions. I was like, oh yeah, it works like this, and it did not. But I think that we've got it now. And then over the next couple months, I spent a little while thinking about this, thinking about some open problems posed at the end of the paper about getting further scalability. And I think that I've managed to do a bit more, although the stuff that I've done is probably a talk unto itself, and I won't be able to go into too much detail on that. I am not Lord Voldemort. Okay, it was not me. I don't know who did it. But a number of people have asked me over the last 24 hours who it was and who I know. I don't know anything. Okay, so with that said, this is how we came to this. So what is Mimblewimble, I guess? It was a neat paper, it's a neat name. In the Harry Potter books, Mimblewimble is a curse that you use. It's a tongue-tying curse that prevents somebody from revealing any secrets. So it's a good name for something that's designed to improve fungibility. I mean, Mimblewimble is fungibility of information spell, although I think this was not described that way in canon. It could be implemented in future, so it's designed for a blockchain. It's not something that we could sort of like add to Bitcoin or something, but a separate blockchain still can be made compatible with Bitcoin. You could soft fork it into Bitcoin as like some sort of extension block or something, or you could do it as a side chain. So these ideas do apply to Bitcoin, and to any currency that you can make a Mimblewimble sidechain of, you will get the scalability and fungibility benefits of Mimblewimble sort of added on to that, whatever the original chain was. So in brief, I'm going to try to make this the most technical statement in this slide. In Bitcoin, the way the Bitcoin transactions are structured, you've got a pile of inputs, a pile of outputs. Every input it's actually an output from a previous transaction that has some sort of secret key associated to it. Every input has to sign the entire transaction, and this proves that the people who own those inputs actually signed off on those transactions, and they do intend to transfer those coins in the way that the transaction does. Mimblewimble is a bit different. It uses rather than having a complicated script system and supporting sort of arbitrary transfers of sort of arbitrary scripts into arbitrary scripts or arbitrary keys into arbitrary keys, Mimblewimble just uses EC keys. And it uses this fact that any two EC keys, you can add and subtract these from each other and you'll get some other elliptic curve keys. And if I have some coins that are attached to some key, and somebody else creates a new key and wants to attach that, wants to say, move the coin from my key to their key, what we can do actually is take the difference of those two keys and produce a multi-signature of the two keys with that difference, and that's just as good as signing one key with the other. So Mimblewimble kind of takes us to an extreme. It takes the sum of all the input keys minus the sum of all the output keys. It will get some single key that is a difference of those two things, and it signs things with that. So because it's really just operational on keys, Mimblewimble is inherently scriptless. It's not like Bitcoin, but we remove script and then we could simplify these things. It's just, I mean, from the ground up, it was designed without scripting, and that's where we're at. Although, as I'll mention briefly a bit later, I think we can get lock times, which are sufficient. We can definitely get multi-signatures, because we're just working with EC pub keys. We can get multi-signatures, and we can also get lock times. Those are sufficient to get unidirectional payment channels. If you have two of them together, you can get bidirectional. You can, in principle, have Lightning on top of Mimblewimble, although not in a very elegant way, but it would work. So I think we can get that, which is the coolest thing. So this is roughly what I said. So Mimblewimble transaction is just a pile of inputs, just like in Bitcoin. The outputs now, one thing I didn't mention, are confidential transactions rather than ordinary Bitcoin transactions, which are a public key and a value. What confidential transactions are a homomorphically encrypted value. And what you can do with confidential transactions is you can add up all of the output values, you can subtract all of the input values as elliptic curve points rather than as values, and you can check whether or not these add up to 0. You can't check anything else. There's sort of a privileged 0 point in elliptic curve groups, and everything else that we're working with looks random. It appears to be a uniformly random point. So all outputs in Mimblewimble are single, uniformly random elliptic curve points. There's really no features to these. So as far as fungibility is concerned, this is pretty cool by itself, that every output looks like a random number. And there's one sort of what appeared to be an annoying feature of confidential transactions is that it's possible to make, it would in principle be possible to encrypt negative values. So I could create an output with negative 1 million Bitcoins and an output with positive 1 million Bitcoins and spend 0 Bitcoins to create these two. I would probably throw away the negative one or leave it on somebody's doorstep. And now I have a million Bitcoins. And the way that we solve this, or the way that confidential transactions solve this, is using what's called a range proof. And the range proof that we use in Elements Alpha is something that Greg Maxwell developed, which proves that every value is between 0 and 2 to the 64 or something. You can make it whatever range you want. But as long as it's much, much less than 2 to the 256, this prevents any negative values. Mimblewimble actually uses these range proofs in another way. In addition to proving that all of the outputs are non-negative, it also uses these range proofs as proofs of knowledge of the blinding key of the output. So the way the confidential transactions work are this homomorphic encryption. They're the key involved here. And Mimblewimble uses this key not only as a blinding key, but also as a signing key. Okay? And it uses these range proofs to prove that the signing key is known, because there are other related key attacks that would be possible without this. And finally, in confidential transactions, you usually add up points. You show that they all add up to 0, and that's great. That proves that all of the input values equal the output values. In Mimblewimble, again, to avoid related key attacks, you can't add them up to 0. They have to add up to another uniformly random curve point. But if somebody produces a signature with that curve point as a key, that proves that it is actually an encryption of the value 0. And we can exploit this in Mimblewimble to allow handing over of keys without the recipient learning the sender's keys or vice versa. That's in a lot of naive ways to sort of try to hand off keys by signing with their difference. You run into this problem. And Mimblewimble solves this with these so-called excess values. So that is, I'm going to try to explain everything from here on just with pictures, I think, because that was a bit too technical for my liking. So here's a picture of two transactions, okay? Two Mimblewimble transactions. We've got some inputs, we've got some outputs. The way that we verify that these transactions are legitimate is we take the outputs, they're just curve points. The inputs are also curve points, so that they're references to old curve points. Subtract them, see if we get one of these excess values. We check a signature on the excess value, we check a range proof on the outputs, and then it's a valid transaction. So this is kind of neat, because the validity claim here is not a bunch of individual signatures signed a bunch of specific data, like in Bitcoin. It's that a bunch of things add up to a bunch of other things, which means that a miner or somebody watching the network can just combine these transactions, and they will get another valid transaction. And there's a bit of an oddity here with these excess values that I won't be able to talk about, but basically you wind up with two excess values and two signatures on these excess values. But that's fine. The original transaction now is you can no longer tell which parts were parts of which transaction. You've got two values, so you sort of know there were two transactions involved, but you can't tell which inputs and which outputs were involved. This is non-interactive coin join or one-way aggregatable signatures, which is something Matt and Adam mentioned earlier. Okay, so that's nice, that's one thing, but I mean, what does this give us as far as scalability? So there's your fungibility, there's your non-interactive coin join. Well, observe this. One of these transactions spent an output of the other, right? These two blue things are the same thing. And if I'm adding the inputs and subtracting the outputs, or vice versa, it doesn't matter. If the same thing occurred on both sides, I can just drop that, or not. These transactions are, one is valid if and only if the other is valid. I can just delete these. And this is something called transaction cut-through, which can also be done non-interactively. So I immediately get a scaling and also a privacy or fungibility benefit here, because whoever owned those blue outputs, they needed to sign off on the second transaction, certainly, that one of these excess values shows us, but these excess values are completely unrelated to the blue output. So now there is no trace that this old output existed, assuming these two transactions were floating around the network and didn't appear in blocks. So there we go, and there's the original transaction for reference. So, I miscompiled that slide, but that's fine. I was going to say blocks are just one transaction because of this. That's it. That's what a block is. It's a header and just a single transaction, a list of inputs, a list of outputs, a list of excess values. So now let's just talk a bit more about scalability. So here is a picture of a bunch of Mimblewimble blocks in a row. These white inputs are Coinbase inputs. Okay, and these actually, assuming we don't have pagins or pegouts or any sort of sidechain stuff, just for simplicity, these actually do not need to be encoded anywhere. Every block adds, 50 Mimblewimble coins or whatever. These don't need to be written down anywhere. Just when you're adding everything up, you just add a commitment to 50 Bitcoins to all these transactions, and that will do it. And then as long as everything adds up, there's your Coinbase. Now, suppose that we've got this Mimblewimble chain, and some new user shows up and wants to know what's the status of the chain. In Bitcoin, you have to download the entire blockchain, you have to validate every transaction, you basically have to replay every transaction in order to see that the current UTXO set was actually arrived at honestly without any transactions being deleted or censored or removed or made up or invalid or whatever. So what we can do here is I can send this person all the blocks, but all the transactions here I can just merge together. Okay, I can take all the transactions out of blocks. The blocks commit to the individual inputs and outputs. So I haven't broken any commitments here. Each input maybe is committed to by a different block. But now, watch what I can do with this cut through here. You can suddenly see a lot of these inputs are actually outputs of all transactions. In fact, every input except for Coinbase inputs are outputs of all transactions, which means I can drop all of these. So I just said the Coinbase inputs that are remaining don't need to be encoded anywhere. So what I give this person who wants to join the network is a list of block headers, the currently unspent outputs, and their range proofs. I don't need any of the old range proofs, they don't matter. And these excess values. If we can't aggregate them any other way, then there will be as many as there were transactions. But for each transaction, I mean, it's a pub key and a signature. That's like 100 bytes or something. So every historic transaction, just with the stuff from the Voldemort paper with no extensions, is now compressed from the perspective of a new verifier to 100 bytes. So all of the, say in Bitcoin, where we've had 150 million transactions in history, this would be like 15 gigabytes of historic block data, plus the UTXO set and range proofs, which in Bitcoin's case, actually, if we had confidential transactions in Bitcoin, it would actually exceed the total size of the current chain, but not by a lot, which is cool. Because Bitcoin with confidential transactions, we've had 350 million outputs total, leading up to 40 million unspent outputs. With confidential transactions, if Bitcoin had this from day one, we'd have like a terabyte of blockchain data. And we can get this, we know how to get this a bit smaller than that, but it's still a lot of data for a new verifier to download. You don't have to with Mimblewimble. The only range proofs you need are on the unspent outputs. Okay? Which is cool. It means that the data that scales with the number of blocks and the number of transactions is very small, and that's growing linearly but very slowly because it's a very small amount of data. And the bulk of the data is now the unspent output set, which grows with the current usage of the chain, and actually it can shrink. You can create a transaction that spends a bunch of outputs, has only one output, and now that's shrunk the total UTXO set. And so in a Mimblewimble chain, you would want to have, in addition to whatever anti-denial of service resource limits you have, you might want to have like a limit on how many UTXOs are allowed to exist at a given block height. And then your fee market would then incentivize people to reduce the UTXO set. So a Mimblewimble chain can actually shrink over time because of this effect, which is cool. I mean, it's not this unbounded, I mean, there is unbounded growth in the linear part, but it's very small unbounded, very, very slow unbounded growth. The real bulk of the chain doesn't have this unbounded growth, even as the chain goes on for years and decades, which is pretty exciting. So let's try to explain the trust model here. So in Mimblewimble, a transaction is considered valid if, first of all, it's non-inflationary, right? You can't create or destroy coins. And this you can verify by checking just that your outputs minus inputs equal your excess values. And secondly, that the owner of the transaction signed off on it. And this is accomplished by this excess value having a signature on it. And if you could combine excess values from multiple transactions, you get a multi-signature, but a multi-signature still verifies that every party signed off on it. So this would not be weakened by any extensions that compress the excess values. Okay, so that's simple enough. That's almost the same as in Bitcoin. In Bitcoin, you have the stronger thing where every individual input has to sign off on everything. And so you know that the owner of inputs signed off on this specific transaction with this specific data without any other merges or additions or anything like that. So, and we can see from this picture that that's what we get here. In the blockchain, so let's consider this new verifier who just downloaded this all. What can this verifier tell? It can tell that a transaction, once it appeared in a block, could not be removed. And this they can tell because they can check the excess values that are committed in every block. They can't tell what the transaction was, just that it appeared at some point, left this sort of shadow, which is its excess value, and that shadow never left. Therefore, the transaction was not just deleted after the fact or somehow hidden from view. Secondly, no inflation occurred. No net inflation occurred. If they look at this cut-through of all the historic transactions, they can still verify the unspent outputs minus the unspent inputs, which are actually just Coinbase. So the unspent outputs minus however many Bitcoins should exist equals 0. But they cannot tell, just with this data, you cannot tell the exact sequence of transactions. So in principle, this new verifier, I could be giving this verifier a false blockchain in which there was a bunch of inflation in the past, and then I quickly cleaned it all up so that in the end there's none left. Or maybe like I stole a bunch of coins but then gave them back exactly to their old owners before this new guy showed up. I wouldn't gain anything by such a forgery, other than like, hi, I did all this proof of work, and now I've lied, but you can't tell. You know, it's not actually an attack, but it is a different trust model than Bitcoin. And I want to emphasize that. So my claim is that as far as a fungible, usable currency goes, this is just as strong and just as useful as Bitcoin's trust model. And it gets you this sort of massive scalability improvement. And again, I've got this picture of our original transaction, and you can sort of see there were these blue coins, but now they're gone. But they're sort of, it's not like they never existed because there's this excess value that has a signature that was at least partially created by the owner of that blue output. So you see these excess values, you maybe don't know which outputs they reflect, but you know that any outputs that ever existed were reflected in those excess outputs. So, oh cool, I have already said all of this. So let me summarize quickly the scaling. So in Bitcoin we have 150 million transactions, 40 million. So what this works out for with Mimblewimble, and these numbers are bigger than the ones I just said, because actually in Mimblewimble I want to use a larger curve for some of the additional stuff that I've done. So this data is a little bit bigger. We can see we wind up with the current UTXO set being something like 100 gigabytes, mostly of range proofs. But the historic data is much, much smaller, and it's growing at a much, much lower rate than in Bitcoin. So I will talk very quickly about syncing signatures because I don't have a lot of time. But from the original Voldemort paper, there's this question, can we aggregate these excess values within a block? This is in general hard to do. You can do some trickery with like variants of BLS signatures, but if you use those, then while you get aggregation within a block, it is possible for somebody who sees a transaction to reverse the transaction by swapping inputs and outputs, putting a minus sign in front of the excess value, and publishing that. And if the excess value does not either sign itself, meaning that when you negate it, the signature is invalid, does something that would allow aggregation, then you have a problem. This suddenly becomes possible. And that's very bad because it means historic transactions, I just said they can't be reversed without rewriting the blocks. This suddenly isn't true anymore. Every transaction now has like one conf security, which you don't want. So instead you can do this scheme where every transaction signs the current block height, and now you still have this reversal attack, but transactions can only be reversed within the block that they appeared, which is true anyway because they can be removed by, like in the block that they appeared, they didn't have to appear in the first place. There's sort of a trivial sense in which they could be reversed then. So this, just by itself doing this, compresses, I said in the last slide, it was something like 20 gigabytes of historic data. Now it's 22 megabytes, which is, I guess, a factor of 1,000 savings. Although there are now a lot of pairings to verify because the way I've constructed these signatures involves pairing, which is a bit slow. So it is possible to do better than this. You can use a variant of proofs of work or the compact SPV things discussed in the sidechains white paper to basically skip a whole ton of headers. So this new verifier now doesn't need an entire chain. I can give them like 300 blocks that happen to have enough proof of work on them to have the same total difficulty as the original chain, where difficulty is measured differently in both cases. And in the original chain, a block counts for some amount of work. If it achieves that target, it counts for target much work. In the compact chain, I say if the block actually got such a lucky hash, even if it well exceeded the target, I would give it credit for all the excess that it did. So this lets me create a much shorter chain of just carefully selected blocks. I provide these blocks using these syncing signatures, which allow these excess values to sign the current block height as well as a bunch of previous block heights. You can then aggregate all of these things, aggregate all the excess values in their signatures, and now that 22 meg becomes 1 megabyte, and you can verify it with unoptimized code in 20 seconds on my laptop. Which for an entire blockchain's worth of transactions, I think that's a pretty good resource load for validation. So unfortunately, I can't go into too much detail. This does change the trust model a little bit. When I do, I need to talk about this. Which, the way that it changes it is that when you do this compression, the compressed chain now has the same expected amount of work as the original blockchain, but the variance there is much higher. If an attacker tries to do like 1% of the work that's required to produce a chain, in Bitcoin, such an attacker has zero chance of producing like a 400,000 blockchain. And we can formalize this. You can actually talk about a proof of work. You can say, if I give you 400,000 blocks in Bitcoin, this is a proof of, I don't know, 395,000 blocks worth of work. Because if you did substantially less than the whole 400,000 blocks work, you have almost zero probability of producing the whole chain. This is no longer true for compact chains. So what I would add to give this verifier are two things. I would give them the most recent 5,000 blocks or so in full, with all the full proof of work, and this will prove 5,000 blocks worth of work. It shows that what I'm giving them was no accident. I mean, it didn't just happen by fluke. Somebody actually did a lot of work to produce this. And I also give them a compact chain going from that 5,000 blocks back to the genesis. And what this does is it incentivizes anybody who would want to maybe produce a forgery. Such a forger would expect to do as much work as the original chain, and so the Satoshi argument that they should rather spend their efforts extending the main chain rather than attempting forgeries applies. So one thing that's proposed every so often is maybe we could just drop historic blocks from Bitcoin and just verify the tip, and then 5,000 blocks, that's a lot of work. Nobody's going to do that. The problem with just dropping historic data is that now there's this so-called incentive cliff, where somebody who does a whole bunch of, who does this much work can forge 5,000 blocks, and if they do 5,001 blocks worth of work, they can forge the whole chain. So only like a whole pile of benefit they get from this one extra little bit of work, and maybe that's worth doing. So we no longer get that. Okay, I am already out of time, so let me quickly just talk about where we are as far as development. I have been working a little bit on a consensus library for Mimblewimble. I've gotten hung up a little bit on the pairing curve selection. I'm actively working on that. In the next couple of weeks, I will try to publish the code that I've got and try to encourage people to help out and give advice and contributions. This is the most boring part of development, so I'm not sure how much enthusiasm I can get, although this is a very exciting project. Once that is done and there's some sort of like consensus library that's written and beaten on and stuff, then you can start doing cool stuff. You can write a peer-to-peer layer, and you can write wallets and stuff, and you can do this in much easier to write, more friendly languages, and you have a lot more freedom to, you don't have to have consensus on that kind of code. So you have a lot more freedom to explore and experiment and do fun things on that side of things. So right now we're still in the boring consensus part of development, but I hope to get past that sooner than later. And as far as sidechains, so I've been sort of saying, oh, well, to simplify this, pretend we don't have a sidechain. We can actually make Mimblewimble as a sidechain. Basically, in addition to all of the unspent outputs, you also commit to a list of peg-ins and peg-outs, and these have to be structured in a certain way. Basically, every peg-in is a signature on an excess value that has to appear, and that will give you a peg-in. And same for a peg-out. And that is it. I am well over time, so I'm just going to stop there. Thank you all.
Thank you very much. Thank you. Thank you. We are running very late, but we will eventually cut the less essential part of the conference lunch. I mean, when is that? And very few questions. One there, two there. Okay. Mike is arrived. One, two. Two questions.
Hi, thank you for your talk. Very interesting. I wanted to know how the fee model would work in such a system. Notably, I think in this system, the fees are also confidential.
Yep.
in the classical confidential transactions, the fees were the only value that was.
That's right.
Not hidden. And in the second question, what curve are you using right now? Is that the same than Bitcoin? Could you use it also on 255.19?
Cool. So the first question about fees, that's a very good question. I talk about this a bit in the full paper that I released a couple of days ago. When you create a transaction, the total input value has to equal the total output value. So any fee you have there, you would release that as an explicit unblinded output value. So you'd have an explicit fee value in the transaction as it's floating around the network, but then the miner would then commit to that amount of fee value and add their own excess value to blind that. And so the miner basically adds his own output to all the aggregated transactions. So on the network, there's an explicit fee. In the blocks, there is not. That's how this works. And for curve selection, I cannot use Bitcoin's curve. I cannot use 255.19. I can for the stuff that I talked about, for the Voldemort stuff, but not for the syncing signature stuff. And the reason is that I need a pairing operation. So right now, just as a working curve, I'm using a 341-bit curve that I came up with that I'll probably replace as I learn more about what I should be doing.
Okay, I think we must cut questions. Okay, we will have a coffee break just under the porch over here, and we will ask you to be back in 15 minutes, not 20. So 15 minutes, 12 and 25. Thanks.
Richiami tu per dire... No, io devo dare l'avviso che non sono permesse public promotional activity.
Hai già detto a Samsung che di...
Sì.
Ok.
If you take your place, the session is going to start soon. Okay. Please let me point it out again. Let me point your attention to the code of conduct. As an academic and engineering focused event, we do not allow public promotional activities. So please refrain from public promotional activities, okay? Thank you, everybody.
So, as a benchmark... Oh. 1, 2, prova. Prova, 1, 2, ok.
Take your seat, please.
Please, guys, take your seat.
Take your seat, please.
We will ask you to hide and take apart every kind of promotional material. As a benchmark, the most you can do to promote your company is to have shoes of the same color like me, but that's just borderline. Please have a seat. Oh. Now stop. Please, guys, have a seat. Let's get back to the beautiful silence we had this morning. Thank you very much. Thank you. So we start the session that separates us from the lunch, which will be like 3 minutes, the lunch, for a talk about community organization. The talk is Build, Scale, Operate, the 3 pillars of the Bitcoin community. Presenting it, Metal Demiros and Eric Lombroso. Thank you.
All right, good morning. This is such a beautiful conference. We were just saying this is a change for normal Bitcoin conferences. So Eric and I are really excited to have this opportunity to speak to you. Want to quickly outline what our goals are, why we're even giving this talk. So first of all, we just want to be really clear. We're not here to try to define any sort of vision, but rather we're here to talk about how we can build more shared vision around how to grow Bitcoin, particularly from a technical and community perspective. So we're going to share some of our personal perspectives on challenges in the Bitcoin ecosystem and how it's evolved over time. Eric from the development perspective, myself more from the business and community perspective. We want to offer some constructive ideas that we've been talking about personally between ourselves and other people who are here today that we could use to begin growing our ecosystem and solicit your input. We've set up an anonymous Google Doc if you want to go in there, like if stuff sparks your imagination while we're chatting. If you totally disagree, you can go in there. It's just bit.ly/scaling ideas. And then the goal is really we want to leave after this conference with some shared goals for next steps that we can take as a community, meaning not only people who've been a part of it for the last 4 or 5 years, but also people who are newer to the Bitcoin community and want to participate. So Bitcoin ecosystem, lots of different people, lots of different stakeholders, but the big point is it's really fragmented. We all have different people we talk to. There are a lot of loosely coupled organizations, a lot of formal organizations, businesses, foundations, loose entities. Some are grassroots and focused on specific objectives, while others are more general and support of the ecosystem. But what's really interesting is this conference is such an amazing opportunity for people from all across these different groups to come together and talk about building a shared vision, which is really cool. So when we say build, scale, operate, what we were sort of thinking is there's really kind of three key stakeholder groups in Bitcoin. On the build side, obviously, core devs and contributors are a big part of this, but also CTOs and engineers that are building products on top of Bitcoin have a lot to do with the way the ecosystem gets built. Academia is driving a lot of the research, whether it's in ways to apply new cryptographic techniques, or whether it's more on the economic sociology and politics of Bitcoin. Business people building as well, product leads. On the scale side, I think there's a lot of vision that goes into this, and our community is lucky to have a lot of people who are visionary thinkers. But there's also marketing and sales and PR and communication and some of the really more traditional ways that we spread the message and share the knowledge about what it is that Bitcoin is actually doing. And then on the operate side, for Bitcoin to work, there's people who need to do certain things, whether it's miners who maintain the network, exchanges who allow people to move money around in and out of Bitcoin, the on and off ramps, companies using Bitcoin in new ways to help it scale and reach new audiences. There are a lot of different collaboration projects like this conference, foundations, and other community groups. And the key is we want all of these stakeholders to work in an organized, collaborative way. It's challenging, but if there are some ways we can kind of work together, it's really helpful. So the challenges, we just tried to high level outline what they are. Bitcoin kind of has 4 key challenges. The first is there are inherent complexities. So the Bitcoin protocol itself has dependencies in it that really can't be solved elegantly, and Eric's going to talk a lot about some of the inherent complexities. There are also accidental complexities just from the way things have been built. This project, started as an experiment, and then people started using it, and now $10 billion of value are in this big network that's been built. So there are real issues here in maintaining compatibility, and so Eric will also talk about some of his thoughts on what we can do here. The third, it may be a little controversial, but I think there's some degree of inadequate methods and techniques. The method of development is really challenging. It's hard to get experience. Meaningful contribution requires a really high level of skill. And there's a lot of nuances and complexities in how we talk to each other, how we work together, how we figure out what we want to do. So what does that mean in terms of growth? And then lastly, one that I feel really strongly about is we're constantly recreating and reinventing when if we shared what was already built and kind of picked optimal solutions, perhaps we can make more progress. So really thinking about how we can stop focusing on problems that have already been solved or building different products that implement the same services or features and start thinking about how to coordinate more so that new features and new services get built and we build best of class rather than just build, period. So with that, I'm going to hand it over to Eric. Eric's going to talk about contributing in Bitcoin. I'm going to talk about operating, and then we're going to share some suggestions and hopefully get some good Q&A.
All right, thank you, Malcolm. So when I first started contributing to Bitcoin, this was around 2011, I started writing my first Bitcoin applications. I started the way that a lot of people probably do, which is I started with the RPC that was built into Bitcoin Core. So this RPC really was not designed for industrial use. It has a lot of serious limitations. It allows you to build some simple applications, but definitely it's not the kind of thing that we really need to be able to build out an entire industry. So I was able to build a couple applications just to see how Bitcoin worked, but pretty quickly I ran into these limitations. So then I had to dig a little bit deeper, and then I realized that the only thing you could really do if you really wanted to have, to be able to do the things that I wanted to be able to do was to actually get into the wire protocol itself. I used this particular document to write several libraries to be able to write some applications on top of this. But this is pretty low level for most application developers. They probably don't want to delve this this level of depth. And most of the libraries that are out there, even though they do abstract some of this stuff for you, you still need to have quite a bit of in-depth knowledge of the low-level stuff. And also, you don't really have good things like account models for wallets, so that you can really query what you need to query and be able to validate everything easily without running a full node. So this is the first pull request that I tried to submit, and as you can see, I was very excited about being able to get this great multiple wallet support. It's complete. And yeah, I mean, this was a really, this is another way that you could actually contribute to, if you wanted to add more features to Bitcoin, you could try to incorporate them into the Bitcoin core software itself. So after the obligatory bike shedding and nitpicking and rebases and doing that over and over again for several months, and people actually really liking it, like this one comment, "This is awesome work. I hope it makes its way to BTC soon." Unfortunately, it didn't work out that way. Eventually, Vladimir closed it, and I don't blame him for that, because it was just getting too out of sync with the rest of the project. And I'm sure that a lot of people have gone through the same experience in doing different things, and it's really frustrating. And it's it's unfortunate that this happens, and people sometimes I think get upset, not necessarily for the right reasons. I think that they're right to be upset that it's really frustrating to contribute to Bitcoin. But the fact is that the process really does have some serious bottlenecks. There aren't that many people that could do the code review, and there's a lot of serious risks inherent in changing this code. So one thing that I've been really trying to push for, which I see is thankfully gaining some traction, and I think that this is something that can really help fix this to a large extent, or at least reduce a lot of the problems, is using layered architecture. So like in the case of the internet, you have a base layer like IPv4, IPv6, which is just how you get packet from point A to point B, and all the way up to the application layer, which actually interprets the data and shows it to the user and has some interaction or whatever. And as you can see, Bitcoin also has a similar kind of structure that we could think of. At the base layer, you have consensus, which is what everyone needs to agree to. And then as you go further up, the compatibility requirements become less strict. So applications might want to be able to share certain data, but it's not absolutely critical. But at the consensus layer, if two nodes disagree, then basically you're going to have two separate incompatible blockchains with different histories, and that is something we're trying to avoid. In this vein, one thing that I've been working on is BIP 123, which the idea behind this is to make it so that BIP authors, when people submit a BIP, they categorize their BIPs according to these layers, and it makes it easier to sort through them and to be able to prioritize them and to be able to see which ones are more critical for review, which ones might not. And at the application level, maybe we don't even need to have any of the core developers review it. You could just build an app, and if enough people like it, great. That's the standard, I guess. But at the consensus layer, that definitely doesn't work. That requires the entire community to come to an agreement. In this particular BIP, I separated it into separated the BIPs into 4 different categories. So at the applications layer, you have stuff like, wallet, like address formats, BIP32. You have, password encrypted wallet stuff. Things that are necessary to be able to have compatibility between different applications, but not necessary for the entire network to function. Then at the API RPC level, you have a set of interfaces which applications might depend on to be able to interface the Bitcoin network. But here, again, you don't need to have just a single standard. You can have several different APIs and several different models for developing this. Then at the peer services layer, this is the actual messages that are sent from between the different peers. Here you do need to have some level of, they need to basically agree on the data format and the messages. But you can always add new kinds of messages, and you can always deprecate old messages, and you can transition pretty smoothly that way. And then finally, you have the consensus layer. And in the consensus layer, everyone needs to agree, basically. If you have any disagreements here, the blockchain will fork, and you'll get 2 incompatible histories. Consensus rule changes are probably one of the most difficult challenges, because this really does require that everyone agree, which is really, really hard to do. It's really hard to get everyone to agree on something. Even if it's something that doesn't seem controversial, engineering always has trade-offs, and there might be some reason that someone doesn't want something, and this makes it really, really, really difficult to change consensus rules. It's just part of the design of the system. It's part of actually what gives Bitcoin value, because the fact that nobody can change the rules from under you means that you have certain guarantees that your Bitcoins mean something. You're going to be able to spend them in a certain way, and people are going to respect them, and the rules are encoded there, so nobody can just change it from under you. But at the same time, this is really frustrating for people that want to innovate on the protocol, because it makes it really, really, really difficult to change things. And there's a lot of mistakes that we can see now that in hindsight we would have designed the protocol very differently, but unfortunately we can't change that anymore, because that would require getting everyone to change, and that is very, very difficult to coordinate. Satoshi made this post in 2010, and he says, and I quote, "The nature of Bitcoin is such that once version 0.1 is released, the core design was set in stone for the rest of its lifetime." So this is basically Satoshi is saying here that changing anything is going to be too difficult. Fortunately, it turns out, he also said that a second version would be a massive development and maintenance hassle for me. So this means that having two different competing clients would mean that any incompatibility between them could cause serious problems for the entire network. It would be very difficult to keep them in sync, which would make things very, very difficult. Fortunately, we've made some progress since those days in finding ways that we can actually do these things, or at least start to do some of these things without these risks. So hard forks are the most naive way that you might think to change the consensus rules. So that's just, I thought that, I think that the transaction format should be this other transaction format because it's cleaner, it's neater, it's more compact or whatever. Well, guess what? Old clients are not going to accept that. And so basically what's going to happen is that the nodes are not going to agree and you're going to get a fork. In the case of soft forks, this is probably the best mechanism that we've had so far, that we've come up with so far, to be able to deploy protocol changes, because it doesn't require everyone to upgrade at the same time. Nodes will eventually converge to a single blockchain, and it's possible to have just a supermajority of miners upgrade to this new protocol, and eventually the entire network can upgrade at its own leisure. It doesn't break anything. It's backwards compatible. This is something that I don't think Satoshi really considered when he made those posts before, but this is the mechanism that's been used exclusively pretty much to add any new features at the consensus layer right now. Then we need to bootstrap a global network. It's just like these crazy guys trying to change the tires of a car while it's moving. The animation's a lot nicer. I couldn't get the animation, but basically, this is more or less what we're trying to do. We're trying to upgrade the system while it's moving, and there's billions of dollars, of other people's money in this, and if we screw up, people can lose a lot of money. So this is not something that we take lightly. It's very, very hard to do this. So this has been a really big problem for being able to innovate at that level. So we have development bottlenecks, which have to do a lot with the fact that we really have a limited number of code reviewers that all have to look at the same stuff. No matter how risky the particular changes are, usually they're going to touch some code that's possibly going to cause some consensus issues or other kinds of node incompatibility issues, which makes it a problem. And then we need more modularization layers so we can have different projects or different sub-projects working more or less independently or with only loose coordination, so not everything needs to go through the same exact threads. And then consensus rule changes. We need better. We worked on good mechanisms to do soft forks, but there needs to be more research on this. There's possibilities for side chains or for other kinds of cross-chain atomic swaps or other mechanisms that might be useful for bootstrapping the system. And of course, we need to be able to do this without breaking anything. So I want to talk a little bit about how the node architecture was set up in the original client. More or less, it's not, this is just, it's simplified a little bit. But for the most part, you have this monolithic system, which is Bitcoin Core. And then you just have this RPC, and then apps connect to it, right? The RPC, as I said before, is limited. It doesn't let you do everything that you possibly would want to do with it, and anything that you want to change inside this Bitcoin core area requires it go through the entire code review process and merge process, and that can be pretty frustrating. So this is something I'm proposing. I think this is we've already pulled out mining from Bitcoin Core, and a lot of the wallet stuff has been pulled out too, but in different ways. We could also pull out the database, and this could be used to actually query, to be able to have different levels of query depending on what kind of applications you want to be able to support. To just do basic block validation and relay, you don't need to store as many indices. You don't need to store, for instance, address indices or transaction indices. But some applications might require that. So instead of forcing that into Bitcoin Core itself, which is always a source of friction because a lot of people, I think quite rightfully, think that Bitcoin Core shouldn't be made into this huge application that does everything. If we could separate this out and make it a shared service, then other applications could use it, and we would not have this problem anymore of people not having a good way of building applications. Then, furthermore, we can also break out the networking part, and then have just validation and relay policy be what Bitcoin, like the crux of Bitcoin Core, and then we could split it out libconsensus, a library that could just do validation, and we can specify policies, independently, and all this other neat stuff. And then once all these things are separated with better interfaces, it allows us to be able to have much more, many more teams of developers working in parallel to work on different aspects of the system without needing such close coordination on everything. Now I'm going to hand it over to Milton, and she's going to talk a little bit about operating in Bitcoin.
All right. So as we think about sort of the development side of Bitcoin, I think what's really interesting from my perspective, again, I'm not a developer, I'm not in that part of the community, I'm more working with the businesses that are being built on top of Bitcoin. If you look at where Bitcoin is today, a lot of companies that were built 2013, 2014, 2015, their business models are dependent on the use of Bitcoin increasing and Bitcoin adoption increasing. And that hasn't necessarily happened, right? So we have this money that's getting poured in at the top of the funnel from investors. There's early adopters and speculators, opportunists in our ecosystem, people who are intellectually curious about Bitcoin. But the core group of people who are interacting with Bitcoin hasn't really changed that much in the last 3 years. So why is that? And how do we get Bitcoin to spread and become adopted in other communities or ecosystems that are much bigger? So kind of thinking about this problem, everyone's seen sort of this Rogers innovation curve. It's not that exciting. But what I think is interesting about it is a lot of people, when they hypothesize where Bitcoin is, they say, oh, we're still in the early adopter phase. Don't worry, right now who's in Bitcoin is limited, but it's going to change. There's going to be this tipping point, and then we're going to have all these people in Bitcoin, and it's going to be great. I don't think that's true necessarily, and I want to sort of explain why. I think Bitcoin probably has reached the majority in its current form, and the actual technical capabilities and feature set of Bitcoin need to sort of change to allow more users to access Bitcoin and build with it. To Eric's point, building with Bitcoin today is really, really hard. This room is probably like 90% of the talent that could do that feasibly. So that's not really scalable, particularly if you're talking about taking this technology and making it broadly accessible. So who cares about Bitcoin today? And so the way we sort of came up with this chart actually was several months ago when the scaling debate was raging back in March. We were having these really interesting internal conversations about, well, why is this happening? Who are the people that are upset with the development process in Bitcoin, and how do we sort of figure out who we need to be talking to? And I think what's interesting from my perspective, I always think about, all right, who actually has the ability to influence what happens in Bitcoin development, and who's actually interested in it? So if you think about that, you start to see today there's a little bit of a mismatch. So obviously the developers building Bitcoin have a lot of influence and they have a high interest in Bitcoin. Miners as well, they're economically very incentivized to be involved in Bitcoin. But then you start going down a few layers and you think about people building on top of Bitcoin. They may not necessarily have the ability to influence the development process. or be sort of a part of that. Same thing with corporates, right? They may have some interest. Today they don't really have any, but their involvement's limited. And then I think the really interesting piece is the holders or the observers of Bitcoin who are on forums, who are in our communities, but aren't necessarily part of the group that's smaller within Bitcoin that's actually influencing development. They care a lot. They care a lot about what happens in Bitcoin, but they have no ability today to influence that development. There aren't really that many roles in our community today. So you have this whole group of people who feels really passionate about Bitcoin and about the technology and about its development and growth, but they have no way of expressing it other than expressing outrage on forums or creating entirely new forums or starting their own initiatives which sort of work counter to Bitcoin's core group. And then the general public, I don't think they care about Bitcoin, nor do I think Bitcoin is for them. So kind of leaving them out of the picture. So what does that mean and why does it matter? So I kind of think about, okay, if we've reached the 100% adoption by all potential adopters of Bitcoin in its current form, we've kind of exhausted this curve over time, right? So we're now in 2016, it's been 8 years. So we've built Bitcoin, we made it work. That was like 2010, 2011. We made it better. There's now this global network. There's lots of ways to get money into and out of Bitcoin. There's all this infrastructure that's been built, a lot of different applications that allow people to access Bitcoin. But we are trying to figure out how to scale it, meaning how do we make it easier for people to work with Bitcoin? And that's, I think, the part we haven't really figured out yet, but we all want to figure out, which is why this workshop's called Scaling Bitcoin. So why does this matter? So if we've reached sort of penetration in this first market and gotten people to adopt it, what is the next target market for Bitcoin? Who's the next group that should care about Bitcoin, and what do they need from a technical feature set perspective, and how do we figure that out? Because we can only grow if we kind of communicate with the consumers of Bitcoin and try to figure out what it is they need and keep that in mind in sort of the development process. So you think again about this group, like where would these people fall on this spectrum if there was a new feature set in Bitcoin? And this is part of the job of core, right? Is they're trying to figure out what are the things we need to add, what are the features we need to implement so that more people can use and access and build on Bitcoin. So again, as you think through these stakeholders, like where are you on this spectrum? How do we think about people that are missing from this? How do we think about all of the successive waves of technology innovation that need to happen within Bitcoin that are going to allow it to scale and reach more markets so that eventually we can realize this vision of a lot of people around the world using Bitcoin, whether they know it and are using it directly or whether it's being used indirectly by the applications and sort of tools they're already using that are simply made more secure, more efficient, more resilient by using Bitcoin as the underlying sort of layer. So that's really hard. And again, I go back to this. Everyone in this picture has really different incentives, but we all have to work together because we all rely on the same core technology to build Bitcoin. And so how do you do that? You can have events like these, you can have forums, you can have private meetings, but how do you really scale that? Because one-on-one conversations are really hard to scale. And I think sometimes we're our own worst enemy, and if people disagree, I'm happy to talk afterwards. I think Bitcoin is not just technical software, it's inherently social software. So how does the group around Bitcoin work? There's three kind of elements you see at play. There's this paradox of this groupthink in Bitcoin that says, hey, this is good and it has to be protected just as it is because this is Bitcoin, big B. I think we sometimes look at external enemies as being a unifying cause. So we find group cohesion in sort of thinking, oh, these are the bad guys, we're the good guys, which pits us against each other in some cases and is not very constructive. And then lastly, the almost religious veneration of these icons we've created, whether it's Satoshi or whether it's parts of the protocol or certain ways things work, has sometimes led to resistance in new ways of thinking about growing Bitcoin. And if people disagree, again, really happy to talk about that. But I think basically what happened, and this is by no fault of any one person or any one design, it's just the way things evolved organically, the system got built, and I think Satoshi, as Eric outlined when he sort of built Bitcoin, had one vision, and he assumed a certain behavior, right? It was more of an experiment. And then users came on, and they exhibited really different behavior. And then people started running the system and realizing that the technical issues and the social issues taking place in the Bitcoin community couldn't actually be uncoupled. They were intertwined in this strange, inseparable way, which happens with a lot of social software. But then the conversational context around Bitcoin, there was this small core group that was talking about, oh, let's plan the future of Bitcoin. That dialogue didn't really scale to include this much bigger group of people who now cared about Bitcoin and really felt ownership of it. So how do you scale beyond that small group? So, sorry, I like frameworks, I'm sorry, it's probably boring, but how do you scale beyond sort of the small group within Bitcoin and make it bigger? So I think there's 5 key components, and they've been talked about at other scaling conferences, but I think Eric and I, again, are really excited about this window we have now. There's a lot of momentum around Bitcoin, and we think there's a great opportunity to sort of work as a community to grow. But knowledge, exposure to or awareness of Bitcoin is really hard. Knowledge is distributed, whether it's on Bitcoin Talk or IRC or Slack or all of these different channels we have. It's not really organized or categorized. I don't know how to do that. I think someone should organize the knowledge. So if anyone feels passionately about that, I think that's a huge opportunity. The second sort of attitudes, a lot of people view Bitcoin fairly negatively. We haven't done a great job really shaping the narrative, which is fine. Like, that wasn't really our role. But I think a lot of it has been due to the lack of knowledge. Like, people have a lot of assumptions about Bitcoin that are wrong at a fundamental level. Like, really, really wrong. So how do you start addressing that spread of misinformation and helping people understand what it actually does and is actually capable of? I think people also don't understand what Bitcoin's actually capable of today. Is not the vision many people think Bitcoin is. Adoption, so the decision about whether or not to adopt Bitcoin, features, user design, experience, these are really important. And today, using Bitcoin sucks. I'm sorry to say it. If you're used to using Venmo or a bank, or if you're used to using an internet app on your phone, like, Bitcoin's not that great because you have this long address and it's really scary when you're sending your first transaction. Like, my first transaction, I checked the address probably 30 times, and then I could have copy pasted it, but I manually typed it and checked it 4 or 5 times because I was terrified, right? And this is what the average person thinks about. It's really hard to adopt Bitcoin because it's not inherently user-friendly. And not just at the user level, but also at the sort of technology level and the innovation level, it's really hard to adopt. And then implementing Bitcoin's even harder. If you want to build Bitcoin into another system or another application, it's kind of impossible unless you have someone like Eric or one of the devs who knows how to go under the hood of Bitcoin and actually make it work. And then lastly, the confirmation component, comparing and evaluating Bitcoin against all the other choices of technology you have and determining if it's actually elegant or efficient. I think academia has a big role to play here, so I hope in Neha's workshop tomorrow that'll be discussed as well. So I want to focus on just these 3. So attitudes, a lot of misunderstanding, a limited body of knowledge around non-technical areas of Bitcoin. I work more on the business side, and the biggest things people ask me is like, hey, we want to use Bitcoin. We're excited about Bitcoin. You'd be surprised to know a lot of banks have people working there who like Bitcoin and who want to use Bitcoin and who want to play around with it. But there's no economic data available for modeling. The way people make business decisions is based on opportunity. And if you can't size or evaluate an opportunity, it's really difficult to sort of make the business case for doing something. And I think the last piece is our communities kind of created a tragedy of the commons where a lot of people who participate or derive value, both economic value and social value from the Bitcoin ecosystem, have not been required to participate. So as you think about, the work that's happening in core development, there are just a handful of organizations who support that project. So why is that? That's a really big problem. Adoption, Eric talked about this, but the feature set of Bitcoin today is pretty limited, which limits its use cases. And I know Core is working hard to resolve these challenges, but there are limited resources and a lot of dependencies. So we need people to contribute more resources, and we need to start resolving some of these dependencies. And then I think the last element is really feedback loops on the feature set. So how do you know what your customers want? Like, who are the customers of Bitcoin and what do they want and how do they prioritize features? I think that's a dialogue that's just now starting. And I hope to see that evolve with people in this room and beyond, but how do we actually start engaging on that front? And then implementing Bitcoin, again, really sucks. It's really hard to find talent. It's difficult to understand how you can actually get Bitcoin into another system, both from an architectural perspective, but also from a dependency perspective. And then does it actually make things easier or more efficient? Or is it just interesting because it's interesting? I think that's innovation for the sake of innovation happens a lot. And we reinvent the wheel here too. A lot of businesses build their own application stacks, their own proprietary technology, when in fact we could just use existing exchange technology, right? Like, we don't, just because Bitcoin is new doesn't mean that everything we build in Bitcoin needs to be new. There are proven technologies that work really well at doing certain things. So I think there's an opportunity there to leverage work that's already been done or standards that have already been created rather than constantly re-innovating and sort of burning all of this time and energy on building. So we had some ideas for projects we could all work on together. So Eric's gonna outline some, I'll outline some, and then we'll have some conversation.
So, so I think, you know, from working on Bitcoin Core quite a bit in the last, at least, especially in the last year, but over the last several years, it's become pretty clear that, you know, we need to resolve these bottlenecks, and I think that we really can make it much, much, much better. I think we can really create a much, much better set of tools and you know, a much better framework for projects. I think separating the dependencies and designing interfaces to decouple them, and then refactoring and re-implementing units will allow us to do this thing in a way that doesn't require everything to be changed at once. It can be done incrementally, and you know, get us to our goals incrementally. So.
And then I think I think we're good. On Bitcoin applications, you know, expanding research in the body of knowledge around non-technical Bitcoin issues and opportunities. I think, you know, this is a technical conference. Obviously, we're focused more on the technical opportunities and innovations, but how do we start engaging people outside of just the development community, because they're equally important, if not more so, in achieving the end goal? How do we think about building infrastructure, whether it's exchanges and wallets or other parts of the ecosystem that need to communicate and coordinate and be able to have an efficient way of working together? How do we manage technical projects more broadly across the community? And this is not at the core protocol level, but more at the application layer, because a lot of applications can use the same sort of infrastructure, and more coordination on the application layer will make it easier for people from outside of the Bitcoin community to come in and use Bitcoin. And then I think the last piece, this is a request I hear all the time, is a reference architecture for how Bitcoin would fit into an enterprise or app infrastructure to ease some of the adoption pains. So let's say I've gotten over the first hurdle, which is learning to love Bitcoin. That's a really big hurdle that requires a lot of knowledge. Then there's a second hurdle if I want to actually use Bitcoin, which is how do I implement and adopt Bitcoin? So I think there's a lot we could do that isn't necessarily tied to core development, but more to the business layer on top of Bitcoin, to make it easier for people once they get over that sort of conceptual hurdle and they're like, oh yeah, Bitcoin, this makes sense, this is actually really valuable, they can then actually implement it and adopt it and do something with it, instead of trying to do something with it and being really frustrated because it's very difficult to build with. So these were some of our thoughts. Thanks for letting us share them. And I guess if people have questions, comments, you can share them on this forum. We're hoping to sort of get a group of people who are interested in working with us in the broader community and maybe building some projects out of this, but would love your ideas and questions. Any questions?
Question?
Here?
Why do you think the companies, like the companies who got VC fundings, are not more investing into core development? You kind of say that core development is a closed group, but if I have the correct understanding, it's quite open.
Well, I think it's inherently very difficult to contribute to Bitcoin without like some very, very special skill sets, which not very many people have. A lot of companies that get VC funding to build these kinds of projects hire developers, and it tends to be more typical skill sets that they're looking for. Unfortunately, right now, the way that Bitcoin works, it doesn't really allow the level of control and like sophistication in application development without these special skill sets. So I think a lot of these companies try to build on top of the infrastructure as it exists, and they end up, for the most part, I think the pattern has been that they end up kind of ad hocing their own backend somehow that kind of works, and then trying to build applications on top of that. But then it becomes very inflexible. It's very difficult to change stuff. It's very, very difficult to maintain those systems. I think Bitcoin Core, the way it's structured and the way that the project was initially created, inherently requires kind of like a generalist knowledge of Bitcoin to be able to really understand what parts to tweak and what parts probably like you shouldn't be messing with. And that inherently makes it really difficult, I think, for companies to collaborate and participate.
And I'll just add to that from the business perspective. Today, there really isn't an incentive or an expectation within our community for people to do that. And so I think that's where some of the attitudes maybe could be changed, or maybe there are ways for more people, even if they can't contribute developer resources, to Eric's point, maybe they could contribute financially or with other resources they have at their disposal to help drive forward not just the core effort, but the broader Bitcoin community in all of the different areas where it needs support. And I think that's been started, but without sort of a driving force to lead that, I think it's really challenging. Core's been really well organized, but the other parts of the ecosystem are a lot less organized.
Thank you very much. Thank you, Eric and Merton. So guys, we are going to have lunch. We will be back at 2:30, not later. So at 2:20, I will start to ask you to come back. There is wait just a second. There is a vegan and gluten-free table. It's just all the way down under the porch. So it's not for everybody. It's just for who asked. Another thing, we asked you not to show or not to distribute commercial material. If there is something worse than distribute it or wear it, is to tweet it. So please do not tweet images with commercial material overlap to the conference. Thank you very much. Good lunch.